Ladies and gentlemen, the second day of Teak International Seminar will commence shortly, and for the smooth running of this program, we ask everyone to please be seated and make yourself comfortable.
Please make sure that all of you have registered at the registration desk.
And please kindly switch off your mobile phones on silent mode. Thank you, your cooperation is appreciated.
Assalamualaikum warahmatullahi wabarakatuh. Good morning and welcome. The honorable respected speakers, moderators, and all participants who are here in person in East Park Hotel Yogyakarta. And also we would like present greetings for ladies and gentlemen who are joining online in YouTube channel from wherever you are.
And on behalf of the organizing committee, we are greeting everyone. Hopefully you all are energized today because we have a fruitful discussion at the second day of International Teak Seminar.
Now we are going to the first session. Allow me to invite our moderator who is present here. He is lecturer on Department of Silviculture, Faculty of Forestry, Universitas Gadjah Mada. He was highly educated and awarded a Master of Forestry Science from Faculty of Forestry of Universitas Gadjah Mada, Indonesia.
And his research interests are urban forest and agroforestry, landscape silviculture and agroforestry. Please welcome Mr. Akmal Nur Jihad Eshud, MSc. And Mr. Akmal, I will hand over the session to you.
Cek. Ya. Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. Thank you Mbak Dian and Mbak Elia that introduced me as a moderator for the first session today, and I'm so glad to be here as the moderator for this session that will discuss about teak plantation. We have 3 speakers for today, and I want to invite our amazing speakers today. The first one is Professor Budiadi, the second is Professor Sri Rahayu, and then the last one is Dr. Dwiko Budi Permadi. So please come to the stage for all our speakers. Okay, so without further ado, I want to directly move this session into the first session or the first speakers. The first speakers will be explain about the agroforestry system in teak plantation that will explained by Professor Budiadi. So Professor Budiadi is part of Silviculture and Agroforestry Laboratory in Faculty of Forestry that he was graduated from Graduate School of Science and Technology, Kobe University, Japan in 2005, and the latest publication from Professor Budiadi is about agroforestry in teak, and then one of the latest publication is Land Cover Change, Biomass Loss and Predictive Cause of Massive Dieback in Mangrove, and then another is Active Learning, Increased Knowledge and Understanding of Wildlife Friendly Farming in Middle School Students in Java, and there are many publications others. And so without further ado, please welcome Professor Budiadi to explain his materials.
Thank you very much, Mr. Moderator. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. In this moment, I would like to present my experience about some experiments in agroforestry, and this is regarding with the utilization of high quality genetic material of teak. So it's the presentation is about the future prospect of using high quality clonal teak in terms of agroforestry system. So my presentation entitled agroforestry system in teak plantation from intensive silviculture to intensive agroforestry. Next. So talking about agroforestry, the basic information is about the population in Indonesia. And as you know that in Indonesia we have 5 main islands, and we are in Java Island, in Java Islands in Central Java, and the data showed us that Java Island is only 6.8% of Indonesia land, and it is occupied by up to 60% of population in Indonesia. So you are in very dense island. This is one of the most populated island in the world. So regarding with the farming system, regarding with the land availability to do such kind of cultivation, we have to understand what is the distribution of the farmland, and also the the availability of the farmland to cultivate the food and the people needs. Yeah. So this is important data to be considered first. Next, and then we talk about the distinguish between forestry and agriculture sectors in Indonesia. We are in forestry. Please point out this. We are in forestry, and in forestry we talk about many kind of timber trees, but it's just very few compared to the availability of tropical trees in Indonesia. We have thousands of tropical trees, but we talk only about 5 to 10 species, including our research in silviculture. We talk about the teak right now. And then we look at the agriculture sectors. In Indonesia also, the agriculture sectors only talk about a few numbers of staple food, rice, corn, and so on, and also some estate crops here. It means that the research in terms of forestry is mainly due to the timber production, timber productivity. And for agriculture, the agronomy talk about the food and some estate crops product. In the center, we have many kind of what we call non-timber forest products. Non-timber forest products that this in Indonesia is very less concern. No, not so many research about the non-timber forest products. Next is so agroforestry here in Indonesia, and especially in our faculty in Universitas Gadjah Mada. Agroforestry is one subject in Faculty of Forestry, not in Faculty of Agriculture. It means that forestry is much more important than agriculture. So we have to to obtain the objective of forestry first, and then we think about the agriculture business or agricultural activity. So agroforestry here is combining the term of forestry and agriculture, but forestry is important, more important than agriculture. This is my opinion. Next. So in terms of what is the agroforestry that the scholars agree to make some definitions here. The first statement, it means that this is the first components. Yeah, the first components in agroforestry is the perennial woody plants. It is the trees, and deliberately cultivated with crops and livestock. This is the additional commodities. Crops and livestock is the additional commodities. Then in our body of knowledge in terms of silviculture and agroforestry, here I make some the position of the agroforestry in silviculture body of knowledge here. In Indonesia, silviculture is mainly for timber or timber management here. So we talk about teak, acacia mangium, eucalyptus, and sorea, and so on, is about timber management. And we have natural forests and plantation forests. Actually, in our law in Indonesia, the system to produce timber is based on the native of the forest. So we have natural forests and plantation forests. In natural forests, we have dendrocarps and so on, and plantation forests. In Java Island, we have especially teak and also acacia mangium in Sumatra and Eucalyptus pelita. Agroforestry is part of the plantation forest because this is man-made forest, and the people in agroforestry, they have objective to produce something else than the timber, something else out of timber. So agroforestry is such kind of approach to manage the land, not only for timber. Yeah, the timber is the main product, but the other products is also to be cultivated and produced. And this is in some condition, food and the other product is much more important for the people compared to the timber itself. Next, please. Then we have the term of intensive silviculture. I think in this discussion we understand well about the three pillars of intensive silviculture. It is tree improvement, what we learn in some decades, and then site manipulation, and then forest protection. And then Mrs. Yayu will talk about the forest protection and also regarding with the teak and clonal teak. Next. And in terms of intensive silviculture, agroforestry the position is about to support the site manipulation, not in the other pillars. Yeah, in site manipulation, we practice agroforestry to improve the quality of the site and so on. To improve the quality of the productivity, we do site manipulation in in terms of agroforestry plantation system. Next, please. Agroforestry is about the only two activity. This species selection and generally we name the species is the components. This components selection, tree, animal, and crops is component of agroforestry. How to select the components, and the second is how to arrange the component. So we have many kind of agroforestry system. For example, agri-silvicultural system, silvopastoral system. When you combine the tree and the animal, we call it as silvopastoral system, and so on. This is about species selection and component arrangement. Next, it is also about the component arrangement. Generally, we have 4 types or 4 models of agroforestry in terms of component arrangement. We call trees, long border, alternate rows, alternate strips, and random mixture. This is also one consideration when we would like to plan the clonal teak using such kind of agroforestry model. We have to choose which one is better for the clonal, the high quality teak. In terms of in Java Island, we have community forest, for example. For community forest, at least trees long border is better. But for the estate forest, the government forest, alternate rows is better. We have Taungya system, for example. I think in Thailand and Myanmar also we have Taungya system. And also the other options is also possible. Next. Next, please. 1, 2, 3. Next. Yeah, next one more. Yeah, this is the components in agroforestry system. So here, I think in this room, we only talk about the trees and the agricultural crops. We know we have no chance to talk about the animal, fish, and also the bee forage here. We just talk about the how many the trees and the agricultural crops. But this is some complexity here because even only 2 components, we have to know well how about to combine between the components. Next, please. Then this is our experiments in Taungya system in Perhutani area in Ngawi district in quite far from here. Planting clonal teak with the dryland rice. This is experience of our team in faculty, and we use the clonal teak as the result of the long time teak tree improvement by Professor Naim and the team, and we introduce dryland rice, some varieties of drylands to be combined in the Taungya system. Taungya system is a system that agricultural crops are allowed to be planted between the 3 rows in the initial period, only for about 3 years, only in the seedling periods of the teak. So we make some experiment plots in the location, and then the result is next, please. This is the model. This is the high quality clonal teak, Jati plus Perhutani superior teak, yeah, and planted with the Leucaena. And this is the 10 varieties of dryland rice. This is first year. The photo is very good. Next, the result, the harvesting of the rice here. This is the teak is still in good condition. The average production of the harvested rice is 9.6 tons per hectare. It's quite high. Some agronomists told us this is higher than in paddy field. Next, please. This is the second year, the production of the rice, and you see the teak is growing bigger. The second year, the production is 7.8 degrees from the first year, ton per hectare. Next. And the third year, the location, the plot produce lower rice per hectare. It's about 5 ton per hectare. The problem is, next please, the problem is that the effect of the tree, the teak tree itself to the rice production. Next. Then it is resulting in 10 years old plantation. This is in different place. This also in Perhutani, but it's also on the Clonal Teak. You can see that the understory of the plantation is nothing. It means that nobody try to cultivate such agriculture crops under the canopy cover of the teak trees. Next. So this is kind of a useless vertical space. This is our concern regarding with the high population in Java. There are needs of farmlands, but we have many useless area under the canopy cover of the high productivity ticks like this. Next. Next, please. So how to manage the understory crops, the understory ecosystem? We learn from the natural ecosystem. As I showed the picture of agroforestry, there are trees, there are crops, and also animals, and also insects. In natural ecosystem, this is quite similar. There are trees, understory crops, animals, and also insects. But all of the members of natural ecosystem are wild species. While in the agroforestry, the components in agroforestry are cultivated or domesticated species. So this is the difference. But in natural forest ecosystem, we learn that on understory ecosystem, there are many understory crops grow well only with the limited sunlight. This is about how to share the resource in terms of sunlight, how to share the resource between the big trees and the understory crops. And we learned that in tropical areas, there are many understory crops growing even only with 2% of sunlight. Next, please. And in the natural ecosystem, natural forest ecosystem, we found many understory crops that this is also still wild species, and we explore. Then we found that some of the wild species of understory crops are useful for the people. Next, please. This the example. This we also know about konjaku. You know, in Japan also you eat konjac. We produce konjaku from Amorphophallus species. This is maybe in Japan, the Amorphophallus is they are grown on open space, but here we cultivate the Amorphophallus under the canopy of the trees. Sit under trials. Next, please. We have many kind of herbal medicines. This is also understory crops, but from one species to other species, there are different requirement of the sunlight, and also different plantation pattern. Also, there are different. For example, this is ginger. Ginger is more on open space, but the problem is also regarding with the combined species here. Maybe there are requirement of the ginger to specific shading from special species of trees. Yeah, this is also complexity of agroforestry experiments in Java. Next, and this is lesser yam. Lesser yam planted under the 15 years of teak in community forest, not in state forest. This is on community forest, and the Dioscorea climb the trees, and the farmer harvest the tuber under the soil, underground, and every 6 to 8 months. This season, in dry season, usually they harvest the tuber. This is one kind of food, functional food for the people surrounding this area in Central Java. Next. And on the old stands, this is our study in Wanagama, the thinning operation on the, at the time, 4 to 5 years old of the teak stand. This is also clonal teak, and this is current projection. And then in our result after 3 to 4 years measurement of the teak, we can find that the clonal teak is high responsive to the thinning. In the first year after thinning, the growth is very high, and then after 3 years, there are conditions that the canopy is going closer again, and then the productivity reduced. So the point here is that using the heavy thinning, the clonal teak responds very well, but this is only due to 1 or 2 years. And then the next 3 years, then the third years, the growth declining like that. So this is also a problem that the intensive management of the clonal teak is very important. We have to learn from year to year to give the proper treatments.
Prof. Budiadi, sorry, could you please to make it short?
Okay, next please. So our proposal is like this. This is an example of permanent intercropping on teak production, and this is as we make experiment about the rice here on the 1 to 3 years. The first 3 years is Taungia system, and then usually stop, and then no longer farming, no longer crops cultivation under the canopy. So this is our simulation to introduce many kind of understory crops, but sequentially divided into different time, different period of the age of the teak. We call it post-Taungia system, and if we can make some such kind of the combination system along the growth of the teak, then we propose on the term of permanent intercropping. Yeah, next. And then by using the intensive silviculture here, I think you know well, and then we combine with the intensive agronomy. In Indonesia, we have panca usaha tani, except irrigation. Yeah. If we can combine, this is for the timber, from the teak, and this is for understory crops, I think we can propose what we call the intensive agroforestry by using the combination between the intensive silviculture and the intensive agronomy. Yes. So the problem, the question is agronomy of crops that adaptive to the forestry system. This is our highlight here in terms of the term of intensive agroforestry. Next. So this is, I think, please some moments to understand these pictures. I think this is the last slides from me. We established demonstration plot in Wanagama. This is what we call the Jatimega, the high quality teak here. And this is 40 years old stand. We did land preparation and soil tillage here, and cultivate many understory crops, including curcuma. This is curcuma and turmeric, and also konjac that not grow well here, and also some Dioscorian that climb the trees. This is the rainy season condition of and if you visit the location on rainy season, you can find the land cover very well. And I just visited the location last week. This is in the peak of dry season of 2023. You can compare, this is the agroforestry plantation area, and this is non-agroforestry area that infested by weeds, Imparata cylindrica. Then this is maybe also problematic for us in terms of the nutrition and so on. So by practicing agroforestry in the old stands, we can manage the understory ecosystem very good here, and this is also, I think, also then will affect to the growth of the old teak itself. Next, please. I think, sorry, the conclusion. Challenges on the clonal agroforestry is we have to diversify the market of non-timber forest product and food for understory crops, and then develop research on integrated and landscape agroforestry. We propose the permanent intercropping instead of temporal arrangement. The Taungya is a temporal arrangement. 3 strata agroforestry and also complex agroforestry. It's all the complexity of the experimental areas, and then we have to assist the farmers because usually we involve the farmer in establishment of the forest and using the clonal teak to practice proper land management in IFFS, integrated forest farming system, with intensive agroforestry. I think that's all of my presentation. Thank you very much.
Thank you very much, Professor Budiadi, that explained to us about agroforestry system in teak plantation. As we know before that, Bapak Natalas Anis have mentioned before that if we want to manage our forest, we cannot say don't touch the forest. Don't touch the forest to the local community because it will destroy our forest. So agroforestry is one of the solutions to address this issue. And we're gonna move to the second speakers, Professor Sri Rahayu, that will speak about integrated pest management in teak plantation. She is part of Forest Protection and Health Laboratory in Faculty of Forestry. One of her research is biomass potential in teak plantation which vulnerable to forest fire. So without delay, the floor is yours, Professor Sri Rahayu.
Thank you. Good morning, ladies and gentlemen. So, in this morning, we would like discuss about the integrated pest management in teak plantation. Pak Budiadi mentioned before, so that now teak plantation in Indonesia not only monoculture but more in the agroforestry. So, please. Okay, as we know that the teak, it is the premium wood. So from premium wood quality, it is valuable tree species, remarkable, required for timber trading and also for agroforestry, particularly in Indonesia, as Pak Budiadi mentioned. Next. Okay, as the fast-growing species teak, so we also develop some clonal trees plantation. Yeah, so this is have productivity. It's high, and also the diameter increment is about 3 centimeter per year, as some of our colleagues in the Faculty of Forestry already have that research. Next. Next. So, with the high input management teak plantation and also with intensive human intervention, regarding to the agroforestry. So this is consequences in the nature that the intensity of the pest infestation is become more. Next. Okay, as we know, this is our about the scheme that due to the climate change and also monoculture plantation and lack of monitoring system, so the tick pest and disease become problem in the our plantation. So some of the outbreak and infestation of pests and diseases, and it will be impact on the economically losses also. So in the session, I would like to share with you all about our pests and diseases in our teak plantation. Yeah, this is some regionally, some locally, but this is become severe from the past up to now. So one of our problem, actually, if the leaf rust by Olivia tectonae, maybe this is also, you have the problem also in other tropical countries because the fungus is typically in the tropical, yeah, but this is not so impact to the old trees, because you know that tick also able to, in the dry season, they able to fall the leaf, so it will be disappear. Yeah. However, if this fungus attack in the young trees, so it will be make the severe because the leaf will become leafless either in the rainy season. So we have this problem. Maybe tomorrow in the field trip we can see many of the leaf rust of a tick. Next. So the other problem is we have pink disease by Corticium salmonicolor, but this problem now become reduced because, as you know, that we already selected 2 clones, yeah. But this is last 10 years already outbreak, because we still using many clone that we don't know yet of the quality. So, but this is, we also have to be aware. So, because the Corticium salmonicolor also associated with some crop, some perkebunan apa, some estate trees. Yeah. Okay, the next. So now we have a problem using our clonal teak. So we have a problem with the bacterial white caused by Ralstonia solanacearum. Yeah, this is many region in Java Island got the problem with this bacteria. This is particularly in the young trees, and also when we still in the nursery, and also in the very young trees before we send it to the plantation. Next. So this is actually only some of the diseases, but we will move to the insect pest. So this is the Captothermes corvigratus. Yeah, as we know that the termite previously they only attack just the cellulose, that it is only outside of the just the skin of the trees. But now with our clonal material, so some termite also attacks the young trees, and the life not only in the bark but also in the young trees, young teak trees. This is particularly from the clonal material. Next. Okay, this is the Hyblea puera. This is the thick leaf defoliator and thick leaf skeletonizer. This is already, the incident already common from the past up to now, yeah. But fortunately, now people become enjoy with the pupa of this larvae, yeah, of this defoliator, yeah, because the price of the pupa of this thick leaf defoliator is become higher. Maybe from the Thailand you also have this, and the price also very high. Yeah. So we happy with this, not become a pest again. Yeah. Okay, next. Now this is the stem borer. This is only attack in the our clone material. As we know that the Duomythus ceramicus, that actually this is no also attack Malaina and also some other forestries, yeah. But this also attack the teak, particularly with our clone material. But this is regionally, not in the all plantation, but only in the specific location. Next. We also have Zeuzera coffeae. This is also the stem borer. This is more dangerous than Duomythus because they will circle on the stem, and then you see that most of our young trees, particularly when they planted at the agroforestry system, it will be very severe, and then it will die, yeah, dry and die. Next, this is Neotermes tectonae, we call inger, yeah. This is our past and now problem, but this is not much on our clonal material, but it's more on the old teak, yeah. We have this problem last time ago, particularly on the old teak. Okay, next. This is the problem associated with our agroforestry system because this is this is associated with some of the crop. So some mealybug also go through our young teak. Yeah, actually this is because behind the teak we also planted some crop trees that, and then the mealybug come to the teak also. Okay, next we also have white grab. As you know, the white grab, this is contaminated, yeah, many contaminated from our organic fertilizer like compost, yeah. Because some of the farmer may be using this organic fertilizer for their crop, so some of the larvae become infested in there, and then the white grab become the problem also. Next, this is the Bemisia white flies. This is only in the nursery, yeah, but it is easy to suppress. Yeah, we have to sanitation, yeah, and then but in the village, and the nursery planted by farmer, it is very also very severe because they don't know how to control these white flies. Next, okay, this is flatted plant hopper Anormenis chloris. Yeah, this is we have outbreak this in the East Java. Yeah, last 5 years. Yeah, this due to the long dry season, and also the condition is maybe, I don't know, maybe in this is the clonal also. This flatted attack severely in this young plantation. Okay, next. Okay, the last is we have also, this is very serious problem in the teak. Yeah, we have mistletoe. Yeah, we have, you see that in here. Oh, cannot. Oh, sorry. Oh, it is this one. As we have observed that when the tick nearby the crop, this is the paddy trees, paddies, yeah, Oryza sativa, yeah. So all the trees here are infested by the mistletoe. Yeah, either this is from the clonal or from the seed, generative or vegetatively. So maybe some bird they transit to this location first, yeah, before they eat in this crop, yeah. So all this here, I have the data. 97% of the trees here have associated with the mistletoe, yeah. But maybe in the next session, maybe in the parallel session, we have Prof. Mutakin, maybe from Nusa Bangsa, yeah, that will be more in detail, will present about this problem in teak plantation. Maybe Prof. Mutakin. Oh yeah, yeah. Next, so finally, based on that problem, so the integrated pest management control have to be conducted in the future, and we emphasize that we have to have forest research integrated, maybe from our country that already have the problem with the pests and diseases on tick, and also forestry planning that also Pak Budiadi and the next Pak Dwiko also will be mentioned. So, and then also institutional strengthening, and finally that we have also people participation and public awareness. Maybe we have to improve building capacity. Next. So the next, so we have to sustainable forest management, and also we still also have to have the biodiversity conservation, and then maintenance and enhancement of ecosystem services, as well as reforestation and forest rehabilitation, and also capacity building of stakeholder, and finally we have to sharing experience and transfer technology, as well as education and exchange the program. So this is our discussion in this session. So thank you very much.
Thank you, Professor Sri Rahayu, for the presentation in integrated pest management in teak plantation. which is become our challenge in managing forest ethic plantation. So the next speaker is Dr. Dwiko. Let's continue to Dr. Dwiko that will explain about forest management in Clonal Teak Plantation. Dr. Dwiko is part of Forest Management Department in Faculty of Forestry. He is also the Vice Dean of Academic and Student Affairs in Faculty of Forestry. His recent activities from Dr. Dwiko is working plan for forestry and other land use netting, full netting in Maluku province, and then enhancing forest rehabilitation for forest multi-business and community empowerment in Wanagama Forest. And the last one is the implementation strategy of Jangka Penah to convert oil palm monoculture to oil palm agroforestry. And without further ado, let's please welcome Dr. Dwiko for his presentation.
Can I sit here? Thank you, Mas Akmal, for introducing me in this very nice presentation, international seminar. I think with my background in forest policy and forest management, it's quite difficult for me to talk about the clonal teak management or the clonal teak plantations. And my last research about the clonal teak research is in 2018 about the policy price in timber for clonal teak. And then in 2010, I also developed a scenario for different rotations for carbon sequestrations. It's a long time ago. And then that's why I come up with this title to see the clonal teak plantation in much bigger view, but narratives in the management of clonal teak plantation from the productivity of timber to carbon trading orientations. These two narratives is quite contesting each other, and then we want to see this narrative based on the evidence of the current research for the last 20 years. Next, my outline of this presentation consists of five. First, about what has been reported on clonal teak. And then second, more questions to be addressed for clonal teak management. And then we can come up with the strengths and weaknesses of these clonal teak plantations. And then we can see what the threats and the opportunities to develop the clonal teak management. And then we come up with the future orientation and some consequences of these plantations. Next. Let's move to the first question. What has been reported on clonal teaks? To do narrative, narrative is about the storytelling. Yeah? So we need big data, actually, to support our evidence on building the narratives. So we try to do scoping Gray literature review on Scholar Google and library repository of UGM and IPB since 2000 and 2023. So this big data will support our narratives that will be presented later. So this scoping Gray literature review aims to provide the research trends and find out the strengths, weakness, threats, and opportunity of the clonal teak plantation. But of course, we add with the more perspective and assumptions. We use keyword for the international publications with clonal teak, and then for the Indonesian publication with Jati Clon, Jati Unggul, and Jati Plus. Yeah. Actually, it can be translated to international also superior teak. I forget to mention that. I think this is work in progress, so it can be reviewed and then revised later. So we classified publication types into international journal proceedings in English, Indonesian journal proceeding in Indonesians, student research, PSC, thesis, and dissertations. So we classify topic based on years, disciplines, and subdiscipline, and roughly to answer the questions for the next slide. Next. So for the national publications in journal and proceedings, we find out 53 selected publications. Yeah. based on Jati Plus, mainly is the keyword mentioned in the publications, national publications, and then Jati Unggul and Jati Clone. Jati Clone just 3, yeah. So we remove some the irrelevant articles. We remove the dissertation, thesis, skripsi for this aspect. Next. We also find out that the international journal, we found 47 selected with the Clonal Teak. And then for the student research, next. The student research, next. Hello? Next. Yeah, no, before. So students research, skripsi, I think in general UGM has more research in Clonal Teak than IPB. Yes, because mainly Teak Clonal is from UGM, expert. Yeah. And then skripsi, BSc, I mean BSc thesis is quite large, 83, followed by thesis, dissertation, and then tugas akhir, in total 105, and then in IPP just 29. Next. So we found that during the last almost 20 years, the research has increased 5 times larger for the last 10 years. And for the BSc thesis is higher than other thesis types at the universities. And recently, more publication in international and national journal in the last 4 years. So this is good for the exchange information and knowledge development in the international level. Next. Based on the countries, this is just for the international journals. Indonesia and Brazil is quite, has a lot of publications, 15. And then followed by Costa Rica, India. I think we have spread, I think Teak or it spreads in every continent, especially not only in Asia and Southeast Asia, but also Africa and Latin America. So we are quite leading with the Brazil also. And then next, based on the forestry science disciplines, forest management and forest silviculture and forest product technology, more research on there, and then less on the forest conservations. So research covered forestry science, more international journals are published in silviculture aspect, followed by forest management and forest product technology, while the national journal are relatively similar, except the forest conservation. Next. So based on the sub-discipline within the forestry science, I think silviculture and agroforestry, as already presented by Prof. Budi, is quite leading in the publications. And then for the forest management, mainly focus on forest biometric, forest planning, and carbon accounting. Yeah. For the forest product technology, wood properties is quite pervasive, and then followed by the wood utilizations. Yeah. Next. So more questions to be addressed based on this big data. Yeah. What is strength of clonal teak plantations? We can answer also, are clonal teak wood properties better compared to conventional ones? Do the wood properties satisfy timber industry and market consumers? Under climate change policy, how clonal teak should be managed? Next, so what is the strength of the clonal teak plantation? This is the productivity narratives. So we agree that almost all publications mention that this is faster growth, higher productivity in stand growth, higher biomass productivity, higher timber yield, volume at the shorter rotation equals to the older forests or stands, and also accumulated more carbon sink in terms of stands, soils, and product. And it improved water and soil conservation for forest rehabilitation because of faster growing. And then financially, it is profitable, of course, under certain assumptions. Next. Next is the weaknesses narratives. We can see from the wood properties and then wood utilizations, it said that no significant different properties compared to non-clonal at same age. I want to friends from Pak Widi, etc., to correct me if I'm wrong. So it said that it means that the older the better properties, of course, with the same dimensions. And then the second one, short rotation result in juvenile wood. Hardwood proportion is minimum, hardwood is more durable and aesthetic. This wood is especially coming from thinning wood. Thinning wood is less, or thin wood is lesser superior, classified as with juvenile log. Yeah. And then, therefore, it's required more treatments for utilizing clonal teak wood for furniture or other constructions wood. Next. Let's talk about the threats, yeah, the threats based on the consumer's narratives. Yeah. One of the competing timber is from smallholder, yeah, from smallholder teak wood. Yeah. It's more competitive because low price, while the clonal teak from industrial plantations with the same quality is relatively higher price. And then the second one, farmers' perception on clonal teak wood is relatively negative. The wood is less superior, they said like that. And then from the consumers' willingness to pay, especially the traders, they ask with the WTP quite lower. Yeah? They ask 20% lower than the basic price of clonal teak wood. Yeah? They prefer to buy teak from smallholder with the same quality, with a lower price. And then the last, clonal teak wood becomes decaying in log pond due to unsuccessful trading. So this can be found in many industrial plantation in Perhutani, but this log that cannot be sold because of this consumer preference. I think I forgot to mention about the vulnerability of pest disease, yeah, in this threat, as already mentioned by Prof. Sri Rahayu. Next, this is the carbon narratives. Under climate change mitigation, what teak should be managed. Carbon trading becomes potential future market in Indonesian national policy on carbon economic value. 60% of climate change mitigation comes from forestry sector. Yeah. So we need to cut 29% emission from in total, and then 60% are from forestry sector. So industrial plantation can sell carbon sinks in the stock market recently, yeah, carbon offset. And then we also have technological advancement on forest monitoring and processing industry affect the management orientations. This is the opportunity, yeah, the opportunity of these developments. Next. And then if we make a matrix, we can see these four narratives, and then we have matrix. How to maximize the strength and utilize all the opportunities. It seems that we need to focus on carbon sequestration as the main product of the clonal teak management. And then based on this opportunity, we can develop precision forestry for monitoring, reporting and verifying the growth and then the existence of the carbon sequestrations in the forest. And then if we see the lower matrix in the right hand, given the weaknesses and the threats, let's abandon timber management orientations. That's the idea of these narratives. But we have two matrix in between that how to overcome the weaknesses using the advanced technology. So the technology to increase added value for inferior wood is required. And therefore, we need to limit clear-cut management options. We need to limit or restrict the clear-cut for the clonal teak managements, and then we can still get the timber from the side product, from the thinning, yeah, not the clear-cut ones. And therefore, the main focus is for carbon offset and trading. And then in the lower matrix in the left hand, the strategy is to maximize the second rotation using copy system. Because based on the research, copy system in the second rotation is quite optimum, while the third copy system is not. Yeah. So therefore, let's do more research in the thinning frequency and intensity, as already mentioned by Prof. Budi, and then what is the optimum thinning frequency and intensity. So based on these consequences, I think we can move from the productivity is already agreed, but we want to sell more in the carbons services than the timber, because the timber need just the inferior ones. We need more technology to process that one for the furniture and construction wood. And then we can still develop a scenario from single rotation to multiple rotations with a longer rotation. So the forest can store more carbons and from the stands and the soil and the product, yeah, because we need technology to make it more durable of these inferior woods. I think that's all of the presentations. I think this is okay. Thank you very much. I return to the moderator.
Thank you, Dr. Dwiko, for the presentation about forest management research landscape, actually. So we have heard the presentation from all of our speakers for the first session today. And so we can move into the next question and answer session. So please raise your hand, mention your name and your affiliation or institution. Yeah. Is there a question? Affiliation? Okay. From the FI. Microphone. Young.
Thank you for this occasion. I want to ask to Professor Budiadi and Professor Sri Rahayu. To Professor Budiadi, how to manage the composition between trees and crops to achieve the sustainable forest, sustain ecologically, economically, and socially, as we know that agroforestry system also give high risk to young trees such as the ladybug, which Professor Sri Rahayu mentioned. And the question for Professor Sri Rahayu, what should the forest manager do to prevent or decrease the pest and disease impact? Focus in agroforestry system of Clonal Teak Plantation, as we know that pests or pathogen can attack in young and mature trees. Thank you.
Thank you very much. We move to the next question first. Maybe Professor Tani. Yeah. And then the last one is from behind. Oh, okay. Yeah.
I have a question to Professor Budiadi. So I just asking about paddy production in this agroforestry system. So in your data, the decrement of paddy production is very much. So, but you guess that this is due to the shedding of the teak. So, but this decrement is very much. So I guess that some monocropping failure of something is happening in this paddy field. So please tell us a little bit more about your discussion about this phenomenon. Thank you very much.
Thank you, Prof. Tani. Okay, we move to the next question.
Thank you very much for your insulating presentation. I would like to ask the first person who present about agroforestry. I am Benjalat Krompen from Royal Forest Department, Thailand. I would like to know that you mentioned on your slide about agroforestry, and you talk about the silviculture method in natural forest, how you learn the method. Because in Thailand, we cannot learn the silviculture in the natural forest. So it's kind of, I want to know your experience about this case. Thank you very much.
Thank you. And the last question. Okay.
Thank you, sir. Good morning. My name is Simon from Laos. So my question may go to the second speaker. Could you tell us more about the best practice for IPM, Teak Plantation Management in Indonesia? Thank you.
Okay, next question from beside Eva. Yeah.
Check. Okay, thank you for the opportunity. Those were a great presentation from the speakers. I have questions to Professor Rahayu. The first is it possible for the disease to jump from trees to crop and vice versa? Because you have mentioned that there is a jump case from insect from crops to the tree, and could it happen to the disease? And if yes, how do we manage if that case happen? And my second question is, how does the climate change and changing the pests and disease impact the strategies for integrated pests in teak plantation management, especially for agroforestry? Thank you.
Thank you very much. For the last question is addressed for Dr. Dwiko, right? Or Professor Rayu? Okay, okay. Okay, so I will provide the first for Professor Budiadi. Maybe you can, Professor. Yeah.
Thank you for the questions and discussion, Ms. Eva. How to manage the composition for the sustaining the agroforestry system. So the scholars offer us to compare the productivity, especially because we have in agroforestry we have 3 indicators. First is productivity, and then second is sustainability, and the third is adaptability. So our discussion in this room is regarding only the productivity. And the scholars offer us to compare the productivity using first what we call land equivalent ratio. Land equivalent ratio to compare the agroforestry system with the monoculture. So the the comparison is usually in between agroforestry and monoculture. So, and if you ask about the ecological sustainability, it is not directly correlated with the productivity. So first we measure the productivity, because sustainability is related with the nutrient cycle, especially on soil, and the productivity is what we can harvest, we can collect from the system. Although this is correlated, but usually we first measure the agroforestry and monoculture is due to the productivity of the ecosystem. So if you have experiment, for example, combining in our study about teak and young teak and rice, then what is the result is how we can conclude is to compare with rice in monoculture of rice and monoculture of teak. Then we can combine the result between teak plus rice in the same place. So that productivity, if you earn that your agroforestry plot is lower in productivity than monoculture, so this is not good. The result is worse than monoculture. So we use land equivalent ratio. Usually the comparison is quite simple, but the problem is how to make the experiment plot, because we have to plant the trees and cultivate the crops all the time. The measurement is all the time, because we have to concern about the trees and the crops in the same periods. Compared to if you cultivate rice, for example, you can only you can get data only in 3 months period. But for the trees in agroforestry, you have to you spend longer time to get the result. And then by combining the result between the crops and the trees, you can compare to the monoculture. So what is the best is to do the comparison. In the agroforestry is must be more productive than monoculture. This is in general, yeah. So because we do not have enough experimental plots, yeah, in the field, due to some difficulties, complexities, and so on. So we have just have some examples about the how to compare the result of the experiments. This is related with the question from Tani Sensei that unfortunately our result from the experiment of clonal teak and 10 varieties of rice has not published yet. But at the time we reduce, we screen from the 10 varieties of rice in the first year, and the second year we have we screen to only 3 varieties, and then after entering the 4th year, there are only 1 outstanding variety of rice. That maybe this is one rice that adaptable to light, to shade of the teak. In the 4th years, quite close, but there are 1 outstanding rice varieties that still grow well. But then, it's still lower than compared to the 1st and the 2nd year and the 3rd year. We call it Situ Patenggang variety. This is also known well to be the rice variety adapted to the light, light shading, not so close canopy like that. So this is a matter of selection, also screening. Then after 4 years of Taungya system, the farmer also know that the productivity is declining and then not economic, no longer economic. So then they stop. This is also the common practice in perhutani area, that Taungya system stop after 3 years of seedling periods. So I cannot show the result of the experiment, but we have the data, although this is unpublished yet. Then we can discuss, and then because Taungya is only 3 years, but we have 17 years after Taungya, post Taungya, up till the harvesting period of the clonal teak by using the rotation of 20 years. The last is silviculture in national forests. Yeah, in Indonesia we have what we call production forest or productive forest. It is government forest that be contracted to the companies. We call it concessionary, and we divide the the government forest, the state forest, into two kinds of management system. First is the natural forest. We call it HPH. Yeah, concessionary that manage natural forest. Yeah, and the species is usually Dipterocarps in Kalimantan, in Sumatra. And the second is plantation forest. This is supporting the industry of mostly for fiber by using Acacia mangium and the Eucalyptus pelita. But in government forest, we have also national parks, we have also protective forests and so on. That cannot be, we apply, maybe we apply silviculture, but the timber cannot be harvested. So the harvesting and due to the silviculture practice is only on the productive forest, inside the government forest. But we have also forest, I mean the area outside forest, this is owned by the people, we call it private forest, that we can freely apply silviculture and assist the farmers to cultivate and plant the trees, including the clonal teaks. This happened in surrounding Yogyakarta areas. Thank you for the discussion.
Thank you, Professor Budiadi. And then we move to Professor Sri Rahayu.
Okay, thank you for the first question. Actually, before I answer the question, so we have actually in the forestry, when we in regard with agroforestry, we have two principles that we have to imbalance. Yeah, we have to ecologically principle and we have also economically principle. If those of the principles are not in balance, so they will some problem look like pests and diseases will be appear. So when this maybe Pak Dwiko will be discussed later, but some of us just intense on economically principle. So that's why very maybe some of the thick species and some crop maybe not compatible ones. So that's why I also will answer Galuh question that some of the pests from the crop and then come to the tick. Yeah, but this is a long time after they adapted the ecosystem. So I also will answer Simon question that we already have the best practice of IPM also, but it is maybe in the result just maybe 50 until 60%. So this is generally I say that this is not easy because we also have to incorporate with many people who interested on the crop, but we in forestry we interested in the teak. So sometimes it is not so smooth in cooperation. Yeah. So we have best practice about the stem borer and the last 7 years ago. So we manage the stem borer using some mechanical technique cutting, and then we reduce also some of the pests using some tanaman bawah apa namanya? Yeah, and under story crop like ginger, like some itu namanya apa? Kurkuma, yeah. Some just many medicinal herb. So and then the insect not attack the plantation because they move to other location because the smell maybe not so good for them. So but it is not easy also. We recorded only about 60%, not the, this is just best practice but not a successful one also. Yeah. And then another question about the climate change. Yes, the climate change is the very sexy topic for everyone. So we also have, as you know, that due to the climate change, the temperature, we know all that thing. Yeah, you know that after temperature increase, so everything become changing. Yeah, particularly with pests and diseases because they have to adapt the temperature changing. So they how to adapt? They become more survive. Yeah, some of them will be die, but some of the adaptive pests or pathogen will be more survive and more aggressive. So that's why under climate change we also have a problem with some more new or maybe the already in the ecosystem, but after climate change they will be improved their survival and more aggressive. So that's why this climate change is will be in the future will be also we have climate change, so we have to be aware about that regarding to the incident and also the risk to the pests and diseases. Maybe that's. Thank you.
Thank you, Professor Sri Rahayu, for the answer. From our speakers before, and I think that is all about the question and answer session because due to the duration for this session. So from our speakers today, either during the speaker's presentation or question and answer session, the discussion we can state that we in a teak plantation, especially in Indonesia, has the challenge and also huge potential to be more developed in the future through maximizing several aspects or challenge, I think. And maybe that's all from me as the moderator for today. Thank you for the speakers, all of the speakers and participants for the enthusiasm during the discussion, and have a great day. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Akmal, and please remain on the stage because we would like to present token of appreciation to the speakers.
And we invite Professor Sumura from Tsukuba University to present the token to the keynote speaker, please.
And we re-invite Mas Akmal to take the photograph.
Next, we will take a photo session together. Please remain on the stage, Bapak Ibu. Already join with us on the Zoom connection, Dr. Kopsak Watongchai, the speaker from Kasetsat University, Thailand. Okay, and also we invite all eminent resources person and all participants to join on the stage to take the photo session together, and also Mr. Kopsak also will join us to get photo session together. Please welcome all participants and the resources person on the stage.
Good morning, Dr. Kopsak. Hello,
Good morning.
Okay. We will
Can you hear me?
Yeah, but we will take the photograph first.
Yes, here.
So we invite all the participants to the stage to have the photo session together. All the students can join us to have the photo session.
Okay. Everyone ready? Okay, ladies and gentlemen, please give your best smile for the pose. Okay. 1, 2, 3. Okay, again. Another pose. Right. Okay, L symbol. L symbol.
L means Lestari.
Okay. Okay. 1, 2, 3. Okay.
Again.
Again. Okay. Once more pose. Please say Jogja in count of 3. Okay. So, ready?
Jogja.
Jogja. Yeah.
Belum.
Belum ya? Okay. Ready?
So many camera. Okay.
Okay.
Ready?
Say Jogja together. 1, 2, 3.
Jogja! And sorry, there is the one participant.
Okay. Please, Mr. join to the photo session. We still wait for you. Okay.
Kandasan.
Still on the frame? Okay, Kanda. Okay? Right.
1, 2, 3. Jogja!
All right. Thank you
Thank
very
you all the
much.
Thank you, and before we go to the second session, please enjoy the coffee break that has been prepared and served at the corner. We will start the first session at 10:30 a.m. Thank you, and please enjoy the coffee break. Dr. Kopsa, we will have the coffee break first, then the second session will start at 10:30 a.m.
Okay.
Thank
I
you.
see. So I will have a coffee.
Yeah, yeah.
Yes, please, Doctor.
thank you, Dr. Kopsak. And for second speakers is Dr. Widianto from Universitas Gadjah Mada. Please come to the stage. And the third speaker, Dr. Laxmi from Thailand. Please come to the stage. Yeah. Okay, so in this second session, we have, please take a seat. In this second session, we have 3 speakers from 2 countries, Indonesia and Thailand. We will talk about fire and teak, anatomical and physical properties of teak wood, and potential wood energy. Yeah, for the first speakers, will Dr. Kopsak, yeah, will the time will be give to the Dr. Kopsak, and I will explain about this session. This session consists of 2 parts, 60 minutes for presentation, and the rest 25 minutes for discussion with all our speakers. So each speaker has time for presentation, maximum for 20 minutes. And with all due respect, I will remind all speakers when there are 5 minutes left remaining. Okay, we will begin this session with our first speaker. He is from Kasetsart University, specialized in forest fire management, forest fire ecology, silviculture, forest ecology, forest protection, and forest insect pests. He got PhD title from the University of Freiburg, Germany, on forest fire ecology. He has more than 20 years of experience teaching students. In addition, he also researcher with more than 15 research projects and publishing more than 15 journals articles and academic articles. Currently, he also holds the position of the Dean of the Faculty of Forestry, Kasetsart University, Thailand. Dr. Kopsak from Kasetsart University, the time is yours.
Thank you, moderator. Good morning. Good morning, participants. First of all, I would like to apologize that I cannot attend the on-site seminar as I promised to some of your colleagues in Gadjah Mada last time when we met. But anyway, yeah, the topic of this seminar is very interesting for me. So I asked the coordinator that whether I can do the presentation online or not. So, and yeah, you give the chance for me. So this is very impression for me. Can you see my slide? Can you see my slide?
Check. Yes, Dr. Kopsak.
Hello.
Yes.
Okay, I will start. So the topic of my presentation today is about the prescribed burning in teak plantations. That we do application of fire to, of course, to reduce fire hazard and also to control some very important insect pests in the mainland of Southeast Asian country in teak forest. So the moderator has already mentioned who am I already, so just I want to skip off my introduction. Just to mention that I do believe that the prescribed burning can practice or can apply in most of teak plantation and also in many different kind of forests in the mainland of South Asia when do managed properly. So I will skip my background. So bring you back to Bangkok, to the Faculty of Forestry. So on your right hand side, you will see the big stump, right? This is the teak stump. It's about 364 years old. It's quite big, right? In the teak So this teak was cut, 364 years ago in somewhere in the national forest of Thailand. So just to show you. Okay, what I would like to present today, that I will divide my presentation into three topics. The first thing is I would like to talk about a little bit about the climate change and forest fire. I will not talk more about the teak because I know that last day and today in the morning you have so a lot of many information about teak in your head already. So I will talk a little bit about the climate change and forest fire instead. After that, I will move into two main sections. The first thing is that I will show you the experiment of fire behavior to reduce field hazards and also to see whether there are some impact on the carbon stock in teak forest or not. And the last session is about the use of prescribed burning to control the teak behavior, the most important insect pest for teak, as you can see from my slide now. So what about the significance of fire in terms of the climate change? So of course, I think you all know that in the global concern, fire can cause the climate change by reducing the carbon sink and increase the greenhouse gas emissions to the atmosphere. So this is the most perception of the many people in I think including me and of course all the researchers. But I would like to I want to stress that there is a bad fire and there is a good fire parallel together. So this is very important thing that we have to concern. Not only bad, but also we have the good fire to do that. In the regional and national concern in ASEAN countries, I think most of us, we use fire for, of course, for deforestation and cause the forest decline. So many people, they use fire for the tool for deforestation. And one problem is that even I agree that fire is very important for many ecosystems in Thailand or in South Asia. But the problem is we have too much fire. We have too frequent. So or that reason fire is bad in the perception of many people. So all forest ecosystem must be under. Therefore, in most countries in the region, it's now illegal to set fire in any forest for any reason. So the climate change now, I think you all agree that the climate change is happening and it's real. And this is the thing that you will see, right? The changing of carbon concentration from 1960 until present day, the concentration of carbon dioxide increased rapidly. Of course, one thing because of the fire, because when you burn the forest or you burn anything, they will produce a lot of the greenhouse gases and a lot of particles into the atmosphere, right? And of course, nowadays you have heard a lot about the catastrophic wildfire. Recently, Hawaii fire, right? It caused a lot of damage to not only the forest but also the household and the life of the people as well. So in terms of the climate change, I think when the climate change happened, so fire behavior change, and that made more difficulty in fire management. So this is the things that will happen. Some of them had already happened when the climate had changed. For example, now we have more fire frequency, we have more lightning, we have very difficult in fire suppression now. We have more intensity of fire now already. So this is the fact. But even we have a very bad view of a forest fire. But as I mentioned earlier, that fire is also we have bad and good. So in terms of forest fire ecology, so when we talking about the factor that control fire behavior, there are three factors that we have to think about. The first thing is that the topography. The second one is the climate condition or weather condition. For example, the relative humidities, rainfall, wind, etc. But both two things we cannot do anything. The third factor that the only one things that we can manage is the field loads, field condition, for example. This is what we have to focusing on when we manage the fire in the forest or in the teak plantation. So just to show you some forest ecosystem in Thailand, we have two main categories: fire-dependent ecosystem and fire-sensitive ecosystem. So in natural teak forest, we have teak in mixed deciduous forest, and these deciduous forest, they are fire-dependent ecosystem. That means fire is necessary for them to survive, and most of the ecosystem they adapt to fire environment already. So let's come to talk about how to manage the fire in the teak plantation. Come closer to the teak plantation, the topic that we are talking about last day, today, and tomorrow that you will have the excursion. So in the teak plantation, of course, there are so many forest fire management program. For example, they have a prevention program that they do a fire break or a field break to prevent the fire from outside the teak plantation. The second thing that I will mention later is about the prescribed burning program for specific purposes. For example, the farmer or the officer, they do prescribed burning to reduce fire hazard. They do prescribed burning for site preparation and also to control insect pests, especially for teak behold border or TBB. And also in teak plantation, we do have a lot of the non-timber forest products that sometimes fire is very important for non-timber forest products. And of course, other practice is about fire control. And recently, we bring the community to do the forest fire management together with the forest plantation. We call community-based forest fire management. So I will focus on prescribed burning. So this just I want to skip about the tectonic statistics in Thailand, because I think our colleagues from Thailand have already mentioned a lot about the teak in Thailand already. So I want to show you some photos of teak plantation and teak, and forest fire management in plantation. So let's come to the second topic. The second topic is about Hello, can you hear me? Hello, can you hear me?
Yes.
It's okay?
Sorry.
Okay, thanks. Sorry. I broke my microphone. Okay. The second topic, which is very interesting for me, is that I would like to know whether when we do early burning or late burning, what happened to our fire behavior in terms of fire intensity, in terms of fuel consumption, and also in terms of carbon loss from forest fuel. So we do some experiment. We do prescribed burning in early of February. We call early burn, and also we do prescribed burning in late of March. We call late burning, and to see what happened in terms of fire behavior and carbon loss. So this just to show you some perception of our experiment in Lampang province, northern of the country. So this is what we do. So we do prescribed burning. And this table just to show you the information of fuel load and fire behavior from many kind of forest ecosystem in Thailand. And this is for teak plantation. So I will show you more detail on that. So this is just to show you the experiment part that we do prescribed burning. And what happened when we do prescribed burning in early burn, when we compare between early burning and late burning. So this is before burning. You see that the most of the coverage of the undergrowth and litter in teak plantation. So most of the coverage is litter from the leaf of the teak. For the undergrowth, not much. And this table just to show you the amount of fuel load categorized by litter and undergrowth and total fuel load. So in total, before we do prescribed burning, the total fuel load is about 8.6 in early burning plots and 7.1 in late burning, and also about 7.9 in control unburned plots. So the field load is not so different before burning experiment. What happened after we do prescribed burning in early burning and late burning? So the percent of fuel consumption, even though the number of fuel consumption is different, but statistically it's not different. That means where we can the fuel consumption because of burning is not so different. What happened? I can't control my slide. What happened? Oh, the hello.
Yeah.
It's hanging.
Yeah, maybe.
Can you hear me?
Still, yeah, we can still see your slide.
Yes, but I cannot change my screen.
Maybe your laptop is hang.
Yeah. It's coming. I think it's coming now, right?
Okay.
Okay. Yeah.
Okay.
Okay.
It's coming back, I think.
Yeah.
Okay. Okay. Where? Okay. So this, can you see the five behavior table? The table. Yes.
Yes.
I think. Okay. For the five behavior, it also not different between the early burning and late burning. So that means the even either the early burning or late burning cause non-significant difference in five behavior. So the residue, of course, most of the residue are unburned material for early burning. In terms of carbon content, before burning, the carbon content in undergrowth and litter is about 40%. But after burning, most of the carbon content is in the unburned material, as you see from the graphic, right? In terms of carbon, the carbon stored in late burning or normal burning, or I would say regular burning, the carbon content, the carbon storage is not so different. And the carbon loss from burning, because we do experiment between late burning and early burning, but the percent of carbon loss is not statistically different. That means even we do early burning or late burning, it's caused non-significant difference in carbon loss. And this is just to show you the photo. So the last thing that I would like to talk about within 5 minutes is about the prescribed burning to control teak behold borer, which is very important, the most important insect pest, I think, for the teak, because the value of teak depends on the damage of the teak behold borer. So we do experiments, we do slash and burn, and we do regular burn, and we compare whether the regular burn or slash and burn will affect to the teak behold borer or not. But the most important is that we do prescribed burning in late April. I mean very late burning. So this is the photo of damage from teak behold borer, which is very serious, right? I think that you don't have it in Indonesia, because last time when we were in teak plantation, I saw we discussed about this insect pest, and I think that you don't have it in Indonesia, but in Thailand, Myanmar, and Laos, we have a lot of teak behold borer damage from teak plantation. So this is to show you the damage from teak behold borer. Yeah, and this is the adult and the worm of the teak behold borer. So what we do for we use the prescribed file to control the teak behold borer. The one thing that you have to know before you do prescribed burning is that you have to know the life cycle of the teak behold borer. and the life cycle of teak behavior is about 1 year. So the very good time to do prescribed burning for control teak behavior is about April, because in that time the adult they mate and lay egg on the tree trunk, so the fire can damage to the adult, damage the egg and young larvae. So what we do? So I have to skip. So this is the data of teak outbreak before we do prescribed burning. We have slash and burn, we have regular burn, and we have control CR unburn. So before burning, the damage percentage is not so different, right? You can see from this the graph. And what happened after we do prescribed burning? Of course, the fire behavior between slash and burn plots and regular burn plot is not so different. But very interesting is that the temperature at the bark of the tree, of the teak, a little bit higher in slash and burn plot. Slash and burn means we do weeding before burning. We do slash and let the field dry 2 weeks before we do prescribed burning. So the temperature of the outer bark of the teak is a little bit higher. What we found, this is very important result. The total damage, the new damage from slash and burn plot is lower than control unburn. This is the result of 1 year after burning experiment. You see that for slash and burn or S and B or B plots, the number of teak behavior is lower than control unburn. This is very interesting. This is very important because that means the burning either by do slash and burn or regular burn in April can cause the decrease in teak behavior damage. So that means we can do application for that. So this brings me to the last 3 slides. That is our implementation suggestion for the farmer. If you want to do burning for controlling the teak behavior, when you should do and what the age of the teak you should do. Of course, there are so many application or implementation methods. For example, you can do chemical control, biological control, you can do light trapping, or you can do planting by doing a buffer zone, or you can do mixed planting, or you do sanitation cutting with different time of the year. You can do that. But for burning, what we suggest is that burning is not good for the teak plantation that younger than 5 years old. But for the teak plantation that about 6 to 10 years or 6 to 15 years old, so the burning application is very important, and you can do prescribed burning in late April to control teak behavior. This is our suggestion for the controlling of teak behavior. What happened for teak that more than 15 years old? The problem for teak that are older than 15 years old is that the teak is taller, the teak is very high. The height of the teak may be more than 15 meters or nearly 20 meters. It depends on the size. So in that case, the effect of the heat maybe not reach the top of the tree, so that the heat cannot damage to the egg and young larvae of the teak behavior. So that's why we recommend the farmer or the practitioners to do prescribed burning when teak is about 6 to not more than 15 years old. But one thing that I have to mention before I finish my talk is that even I suggest that burning is very important to control teak behavior, but we have to concern about the frequency of burning. I do not recommend to do prescribed burning in teak plantation for every year. This is not my recommendation. So we have to think about the frequency. That means we have to do prescribed burning some year and we have to protect the forest, the plantation for some year, and then do it again for prescribed burning, but not burning every year because you will destroy all of the ecosystem in teak plantation. So thank you very much for your attention. I have to thank you for Foreign Industry Organization and also the National Science and Technology Development Agency of Thailand to that give me the funding the funding to do my research that I show you. Thank you very much.
Yeah. All right. Thank you, Dr. Kopsai, for your insightful presentation. For all participants, please keep all the question or maybe until the discussion time. And now we will move to second speakers from Universitas Gadjah Mada Indonesia. He is an associate professor in the Faculty of Forestry, the expertise of wood formation and quality improvement. He also holds the position of Vice Dean of Academic, Student Affairs and Partnership in Graduate School of Universitas Gadjah Mada. He got the title of PhD from Tokyo University of Agriculture and Technology in 2012. And until now, he has more than 26 publications on international reputable journal. He also very skillful as a musician, a guitarist, and bassist. He has a lot of fans in our faculty, balancing academic and music, right, Dr. Widianto? Okay, without further ado, please, Dr. Widianto Dwinugroho, and the floor is yours.
Thank you very much, Mr. Moderator. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello, good morning, everyone. Today, I would like to present our study entitled Anatomical, Physical, and Mechanical Properties of Clonal Teak, especially in the Clonal Teak, 20 years Clonal Teak from Ngawi, with 3 different treatments. Our team, Professor Widiatno, Professor Ganesh Lukmandaru, Professor Naim, and also Aris Wibowo from Perhutani. Everyone, as we know before, that teak wood has a very good wood quality and also very popular in Indonesia for the housing component and also for furniture. And the supply of the demand of teak wood increasing. However, the supply of teak wood become decreased. Next. Okay. This is the background of our study. I continue that the supply of teak wood decreased. Therefore, a kinetic improvement program to increase the timber production from teak plantation has been conducted. Yeah, especially from Perhutani and also in collaboration with the Faculty of Forestry to produce the better clones of teak wood. Some researchers reported that the superior clone have selected for the establishment of weather plantation in Java. The clone showed the good performance in growth. The productivity was accelerated very dramatically. Very good growth. Next. Yeah. Some effort was conducted to improve the quality of teak plantation, such as the intensive silviculture technique, including the side stand manipulation, thinning, pruning, griddling, and other treatment to improve the wood quality and encourage or to stimulate the diameter or radial growth of the tree. Griddling also popular for the teak wood to improve the wood quality, especially before harvesting. Normally, teak wood was griddled around 2 years before the final cutting. But in this study, we try to make the 3 months treatment for grittering. As we know that there is still limited information about the wood properties from the 20 years old clonal teak wood. Yeah, some researchers already conducted the similar observation to evaluate the wood properties. However, for the 20 years teak wood from Ngawi, there is still limited information. Therefore, we evaluate the properties of wood to examine the quality related to the next utilization. Next. The objective of this study, 1, to evaluate the physical properties of 20 years old clonal teak wood from 3 different conditions. We have 3 different conditions. There are thinning, without thinning, and thinning, then followed by girdling. And the second, to evaluate the mechanical properties, and then we also evaluate the anatomical properties. Next. We can see here the material and methods that we select the 20 years old clonal teak from 3 conditions. We collected 3 samples or 3 trees from the stand, teak stand without thinning, and then 3 trees from the stand with thinning. The thinning was conducted into 2015, and also we collected 3 samples from the stand with thinning and then 3 months girdling. Yeah. The stand on the trees was collected from the Wali Kukun, Ngawi. And probably tomorrow we will visit this area to see the real plantation, teak plantation of 20 years clonal teak. Next. We can see here this the photos of 3 conditions of our samples. This we can see here. This is the condition of the stand without thinning. We can see here the diameter smaller than others. In the other hand, the thinning treatment can stimulate the increment or radial growth. This very significant, I think. The thinning, improve the quantity of the developed wood. Next. We show the diameter. We can see here. We collected also the data from the bottom part, the mid part, and also the top part. We can see here that from the bottom part, for example, here that the thinning treatment stimulate almost 2 times the diameter of trees. Next. And here I will show the method for the mechanical, physical, and also anatomical observation. We collected 3 parts within 1 tree. We collected 3 parts of logs from the bottom part, from the middle part, and the top part of each trees. And then we spread it to various evaluation. For example, for mechanical testing, for physical properties testing, for anatomical characteristics testing, and also for chemical properties testing. However, in this chance, I only show the data, the mechanical, physical, and anatomical testing. Probably in the next chance, we will show the chemical properties result. Next. And then from this logs, we spread also. We divide into some sample from the observation of mechanical properties, according to British standard. Physical testing also according to British standard, and then anatomical observation according to EAWA. And then we collect data from several parameters. For example, we also collected the data from the physical condition, not only physical properties, but also physical condition for example, the hardwood ratio, wood color, slope of grain, and also the presence of crack. Next. And here I will show, this is the several kinds of parameters that we conducted in the laboratory. Next. Next. Yeah. And then the study showed that the data like that for the physical condition of wood, hardwood proportion, we can see here that the thinning treatment stimulate the diameter. Thus, the proportion of hardwood also wider than the normal wood. Normal is mean that without thinning. The treatment with thinning accelerate the growth or lateral increment and so the wider hardwood, compared to the thick wood without thinning. I think the thinning and thinning with girding has a similar, almost similar portion of hardwood. Next. The second, we also evaluate the wood color, and the study showed that the trees with girding treatment improve the quality of color. Why? They has the brighter and fresher, not pale, compared to the other treatment. Therefore, girding, significantly improve the quality of color. Next. For orientation of grain, for other treatment, there are no significant difference. We collected almost similar data. All of sample has straight orientation of wood grain. Next. And then it is very important for the, I think for the Clonal Teak breeding program, we also collected the data of initial crack. We can see here that the normal trees or without thinning, they still have the crack. And the thinning method increase the frequency and the size of crack. Therefore, we accelerate the growth is okay, but there are some potential crack. Increase the potential crack. And we have the good news. The girdling might reduce the potential crack. Therefore, we can accelerate the growth, but we need to follow by another treatment. There is girdling to minimize the occurrence of cracks. Next. Then the second one, we would like to discuss about the wood physical properties. At first, for the moisture content, there is the normal result. I think everyone knows that the girding treatment reduces the moisture content of wood. Next. For the specific gravity, we can see here for the wood thinning and girding almost similar, but the wood from the thinning, so the slightly higher specific gravity of wood, and belong to according to Marta Wijaya, the wood belong to strength class number 3, and I think almost same with the previous study conducted by Hidayati and also Seta. Marta Wijaya, I think he used the old trees, and the trees reported has a higher specific gravity. There's still a challenge for us how to increase from the lower specific gravity to this point, around 0.7. Next. Shrinkage of wood. We can see here that radial and longitudinal shrinkage of wood have no significantly different. In radial, yellow, and tangential, longitudinal, Yeah, gray. But for the tangential shrinkage, slightly different. Yeah, that thinning and griddling has the higher shrinkage value. Next. For T and R ratio, yeah, we can see here there are no significant difference among treatments in terms of T per R ratio, tangential by radial ratio. That's the data show the dimensional stability of wood. Next. And then I would like to show the data about the wood mechanical properties. We can see here that the thinning treatment increase some mechanical properties. For example, they has the high modulus elasticity and also the strength of cleavage. Yeah. Therefore, the treatment with thinning followed by griddling could improve the mechanical properties of wood. And then after thinning and then followed by griddling, they has also higher mechanical properties. Therefore, thinning is potential treatment for clonal ticks. And also griddling very important also for improving the wood quality. Next. And then we can show here, this is the Marta Wijaya also for the reference. We can categorize the wood to the strength class. We can see here some from the wood density or specific gravity, static bending strength, and compression strength. Some of parameters are still strength class 3, but from the static bending strength, all of treatment show already the second class, in the second class. This, I think it is the good news for the tree breeding program, especially for the clonal ticks, but I think it is possible to increase the quality of wood in terms of the strength class. To improve the wood density, to improve the static bending strength and compression strength. And it is compared to the another result from the previous researcher. Almost similar, but probably this our goals. This strength class 2. Next. Still 4 minutes. Mr. Moderator Mas Fikri, you still have time. This is the last data about the wood anatomical properties. I think this is not so related, closely related to the wood quality, because especially wood anatomical properties related to wood quality in terms of the pulp and paper, fiber properties, fiber utilization like that, or for the academical analysis. But we can see here that the thinning, yeah, could improve the formation of fibers. Yeah, the thinning. Probably they get more nutrition, they get more the sunshine like that, and then the fiber formation get acceleration. Next. From the data, we can conclude that the treatment with thinning followed with gluten could improve the wood color and reduce the initial cracks. The second, the wood density ranked from 0.51 to 0.54, yeah, categorized to the strength class 3, and wood from thinning treated trees show higher specific gravity of wood. Yeah. Thinning treatment followed by acceleration of growth in diameter did not reduce the resulting specific gravity. And gluten treatment reduced the moisture content of wood. And then wood from trees with thinning showed better than wood without thinning in terms of wood mechanical properties. In addition, the wood treatment with thinning and followed by griddling also showed the better mechanical properties. Next. We can see here that the anatomical characteristic, yeah, thinning treatments could improve the some properties of anatomical properties. such as fiber length and fiber proportion, and the treatment with longer growing period is needed to determine the optimum growing period of better result. In this case, I would like to say again, our study, we only use 3 months growth length. Probably longer growth length will get the better result. Next. And we still have next challenge. For example, when the optimum period of growth length, we need longer period or not. And the second is the 20 years old teak still in juvenile period or already enter to the mature period. We don't know. It is needed to investigate the boundary between juvenile and mature wood area. Third, it is possible to reduce the juvenile age, and if it is possible, how to reduce? Is it possible to increase the farm hardwood? Because the hardwood also the important parameter for the wood value. Still question. How to accelerate the hardwood formation? Also still question. How to minimize the initial crack? Observation the growth stress of trees is needed. And probably still many more questions for us. That's all my presentation. Thank you very much for your kind attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Yeah, thank you very much, Dr. Widianto, for the great presentation. We still have 30 seconds left. Okay, now last but not least, the next speaker has come from Royal Forest Department, Thailand. The most beautiful speaker in the session, yeah, and yeah, she is a director of Technology Extension and Transfer Division, head of Forest Technology Extension and Transfer Center, Saraburi Province, have educational background for a bachelor degree in forest biology in Kasetsart University, Thailand, Master of Science in Biotechnology, Kasetsart University, Thailand, and she has a lot of research experience on biogas and renewable wood energy since 2010. And in this afternoon, she will share knowledge to us about energy potential of teak residues from forest plantation. So without further ado, please welcome Dr. Laksmi Sutiwilairatana. The floor is yours.
Good morning, ladies and gentlemen. Let me introduce myself again. I am Laksmi Sutiwilairat. I'm the Director of Technology Extensions and Transfer Division, Royal Forest Department, Forest Research and Development Office from Bangkok, Thailand. And I'm also the Chief of Forest Technology Extensions and Transfer Center in Saraburi Province, the city in the northeastern part of Thailand as well. So before going to my presentation, I would like to take this opportunity to say thank you to UGM and JCAS that give me chance to be here to listen to many interesting presentation and visit a nice city like Jakarta. What I'm going to talk about is the energy potential of teak residue from forest plantation. It is conducted at the Forest Technology Extensions and Transfer Center at Saraburi Province. By collecting the fallen small branches and leaves of teak to collect from the botanical garden, Phuket Botanical Garden near to my center to The purpose is to reduce teak residue and increase value of residue by making bioenergy products. So my objective is study the energy potential of small branches and leaves of teak by making charcoal and charcoal briquette. For my process, I have 3 steps. Step 1, first step is the charcoal making of residue by high efficiency single dump kiln and smokeless kiln. In the picture on my left hand side, you will see the single dump kiln of IFD named ST1, and on the left hand side of mine, you will see the smokeless kiln. For these 2 kilns, it is an indirect operation system of pyrolysis. For SD1, it is suitable for small branches, and for smokeless one, it is suitable for leaves. And the yield of SD1, it can give a charcoal about 20 to 40% by weight, and for smokeless one can give a yield about 30 to 50% by weight. Step 2, charcoal briquetting of small branches. Charcoal by briquetting machine. After we get the charcoal, and then we will put in the grinding machine, in mixing machine, and last in compressing machine. For the third step, we will analyze the calorific value of charcoal briquette by bomb calorimeter. This is we'll do in the laboratory in Bangkok. This picture shows you charcoal processing of small stem. This is the additional study. My title is focused on the residue such as small branches and leaf. But this picture, I will also want to show you the charcoal of small stem. At that time, I heard that another center in Clonal City, Silvicultural Center, they thin their teak plantation and they have some small stem. So I asked them to get the small stem, the diameter about 10 centimeter to study as well. So in the picture, in the picture, you will see the small stem of teak, and we will cut it into about 10 or 20 centimeter and put it in the kiln. And this small stem use a kiln named SD1, and you will see the characteristic of the charcoal. Charcoal processing of small branches. The small branches of teak were cut in a small, like a small stem. The length is not over 20 centimeter, and we use the high efficiency single dump kiln SD1 to burn it, and can get about 25% of charcoal. And the picture shows you the characteristic of charcoal from small branches. Charcoal processing of leaves. For the leaf, we use a kiln, the smokeless kiln, to burn it. We put it in the kiln and then burn it, and you will see the characteristic of charcoal of leaf in the picture. You will note that the charcoal of leaf is the shape is still be the same as before burning. And after I get the charcoal from small branches, I will see that some piece is big and some piece is very small. So for the big one you can use and for cooking, but for the small one it's difficult and it's not convenient to use to put in the cooking stove. So I bring the very small one to make it in form of easy to use and more convenient to use. So I bring it to make a charcoal briquette. Normally, charcoal briquette is mainly composed of two parts. Component one is the charcoal powder, and the second one is the binder. For my study, I use the tapioca starch for the binder, and the ratio of charcoal powder per tapioca starch is 10:1, and we mix it with some water and put it in the briquetting machine, and then place it and can get the briquette as shown in the picture. For the result, on my right hand side, it is a calorific value of raw material before burning. Calorific value is only one indicator to tell that this charcoal or this fuelwood is good quality or not. And the left hand side, this is the calorific value of charcoal after burning. You will note that in the first picture, the small stem of teak can provide calorific value of 4,518 calories per grams. And then after burning, charcoal of small stem can provide calorific value about 7,853 calories per grams. It is increased. In the same way, for the small branches and for the leaf, after burning, it can provide calorific value higher than before burning. Compare the calorific value of charcoal briquette. When it was fuelwood, it provides calorific value about 4,500 calories per gram. After burning, it can provide calorific value about 6,960 calories per gram. But after make it in charcoal briquette, it can provide the calorific value about 6,607 calories per gram. It is a little bit decreasing. This is the picture show the usability testing of charcoal briquette. Normally, charcoal briquette can not only generate heat continuously, but also produce no smoke and no odor during combustion, and it is in form of easy and convenient to use. Next. This is a calorific value comparison between teak and other species. From the table, for teak, when it was fuelwood, it provides calorific value of 4,518 calories per gram. And after burning into charcoal, teak can provide calorific value of 7,853 53 calories per gram. Compare with another species, you will see that Casuarina ethicetifolia provide the highest calorific value of 7,890 calories per gram of charcoal. And Acacia mendium is provide lowest calorific value of 6,821 calories per gram. This is just an example, not all species, just some species that I list for you to see. Next. Calorific value comparison between charcoal briquettes of teak residue and other raw materials. As you have seen that we bring the residue of teak and make a charcoal briquette. Charcoal briquette of teak residue can provide calorific value of 6,670 calories per grams, whereas jackfruit residue from the table, jackfruit residue can provide the highest calorific value of 6,980 calories per grams. And banana barks, you know banana barks of banana. It can, after being charcoal briquette, it can provide calorific value of 5,718 calories per grams. Next, please. Okay, I think everyone knows that charcoal can absorb some smell or bad smell in your refrigerator, in your shoe rack, or in your room. But when you only put a lamp charcoal in the basket or in the container and put in your room, it look not nice. So we try to make it in another shape, like a heart shape, animal shape, flower shape. So when we put in our room, it will look more lovely and more beautiful. Next, please. And this is my product. I call 2-in-1 flower waste or healthy flower waste. Normally, the flower waste has only waste and flower, but for my 2-in-1 flower waste, I also put charcoal. I make it in a small piece like a coin, and put it in the waste. So my product is not also for decoration. It's not only for decoration, but also used for absorbing the bad smell or the unpleasant smell as well. You can see black when I talk about charcoal, but this picture you can see a little bit more colorful. And this is only my product. And my friend or the familiar people in the occasion like New Year Day, birthday, or promotion, their position, they will ask me to do this flower waste for them. Next, please. For my study, charcoal of small branches can provide calorific value of 6,960 calories per gram. It is considered for general cooking according to community product standard, not less than 6,000 calories per gram. Charcoal briquettes of small branches provide calorific value of 6,670 calories per gram, and it is considered good for grilling or cooking as well, according to community forest community product standard, not less than 5,000 calories per gram. Next, please. About teak leaf. Teak leaves can be burned into charcoal, but charcoal of leaves, the form is not suitable for cooking and not suitable for making charcoal briquette. So it is appropriate to use as biochar for soil improvement. Next, please. Now, I think maybe someone or the new generation will think that do we still use charcoal, or don't we have a high technology? According to the center, to my center, Salaburi Center, we focus on the local people, not in a small scale, not focus on the big scale or large scale. So our technology, the technology should not be high, and the cost should not be expensive. The utilization should not be hard. It should be practical for the local people. I think for my study can be used for the guideline for in terms of residue utilization for sustainable management of forest plantation. Thank you very much.
Yeah. All right. Thank you very much, Dr. Lakshmi. Now it's time for discussion. Yeah, I will open for the first Q&A session with maybe 3 participants. Please raise your hand, mention your name and affiliation, followed by the question to the speakers, please. Maybe anyone question? Or maybe someone will share experience, please. Okay. Yeah, anyone? Okay. Once more, maybe. Anybody? Okay, maybe, yeah, sure. Maybe, please, for the committee.
Thank you. I want to ask to Dr. Kopsak from Thailand. I have 3 questions. The first question, how can people do prescribed fire to control beehive borer in community forests? And then, are there any rules for doing that in teak plantation? And the last question, what is the effect of prescribed fire on the quality of teak wood? And the second question to Dr. Lakshmi from Thailand. Okay. Is it possible if people take the small branches in teak plantation to produce the coracle or briquette for selling? Yeah, enough. Thank you.
Okay. Yeah, maybe for the second participants.
Okay, thank you. I'm Rafi Fabiama. I would like to ask Pak Widi and Lakshmi from Thailand. So for Pak Widi, is an interesting research, I think. And as I saw, you use like maybe 20 years for cutting or produce the wood from the clonal teak. I want to ask that, is this, the tree is categorized as a fast-growing tree species, or is still not yet known as a faster-growing tree or slow-growing tree in the future? Because as far as I know, fast-growing tree in terms of durability is less durable compared to the slowing-growing tree. So based on your research, I saw that from the tining and binding is a good compared to tining in the cracking area. But I want to ask, in the future, is there any side effect of the treatment from tining and binding in terms of durability of the wood itself? Okay. And for the Lakshmi, I want to ask, is for my curiosity, you use the charcoal in the flower paste. So I want to ask that the charcoal that you use in the flower paste is to change the media of planting or just for decorations in the flower paste? Thank you.
Yeah, thank you. The last participant, please.
Thank you very much for interesting talk. My name is Kiyosada Kawai, belonging to Japan International Research Center for Agricultural Sciences, JIRCAS from Japan. I have two basic questions to Dr. Yudianto for about the wood color you investigated. First question is, did you measure wood colorness in air-dried or fresh conditions? First question is, did you measure wood colorness in air-dried conditions or fresh conditions? The second question is, you presented the data that gathering cause more brighter wood, but is the brighter wood more economically valuable compared with less bright wood in Indonesia?
Yeah. Okay. Thank you. Maybe we'll move directly. Maybe for the first opportunity for Dr. Kopsak, you can respond to the question, please.
Thank you. So for my point, I have three questions from the floor, right? I have three questions from the floor. Yeah, I get the first question and the third one, but the second question I cannot get it. So could you please repeat again for the second question for me? Because the first question that you asked about how to use the fire in the community forest, and the third one you're talking about the effect of fire to teak quality. But the second question, I cannot get it. So what is the second question for me?
Yeah, maybe for the second question, for the prescribed burning, maybe the rules of our condition that we must to fulfill before conducted the prescribed burning.
So please speak a bit loudly because it's very. I can't hear you. So please speak more loudly. Please speak loudly. I can't hear. Yeah, please.
Hello. Can you hear my voice clear?
Yes. Now. Yes.
Yeah. The first question.
The first is okay, but the second question, what about the second question?
Yeah, the second question, the effect of the quality, right?
Mm-hmm.
The effect of the prescribed burning to the quality of the teak, the remaining teak after burning. Yeah, maybe you could explain more about the quality of the remaining teak tree.
Okay, okay, thank you. So the first comment from the floor is about how the community forest they can do prescribed burning, right? So I would say that in Thailand now, when the community would like to do prescribed burning, so the government they allow them to do prescribed burning. Yeah, either in natural forest, I would say in community forest, or in the teak plantation, their own teak plantation. But the thing is that you need permission first. So that means you have to submit the application form in application and ask for the burning permission. So you have to declare where you want to do prescribed burning, when you want to do prescribed burning, and what about the practice that you have to do for prescribed burning. After you do application, you send the application to the government. So there will be a committee that approve your application, and then they will send you back like the message that okay, you can do prescribed burning when and where and how, for example. So this is the things that the local people they have the chance to do prescribed burning compared to in the former time when we don't have any system like the application permission system. So the local people they do their own burning. They don't ask any permission, but now they have to. We have many system of the permission system. So that's the first thing. So of course they can do prescribed burning now for the first question. But the thing that I would like to share to you is that even though now the local people they have the chance to do prescribed burning in teak forest or in the community forest, but they need more detail on burning practice. I mean, how to do burning. They need more detail on burning period. They need more detail on the tools. They need more detail on the what kind of burning techniques you use in your plantation or in the community forest. That is the thing that the community need to have that information, and the government have to prepare that information. The government have to do like a manual for burning prescription. So this is my first declare. And the second question, you are worried about the impact of the burning on teak, for example, for wood quality. I would say that in terms of wood quality, I do not have the experiment that looking on the wood quality, the effect of burning on wood quality. But we do have the experiment that we looking on the growth rate, the teak growth after burning experiment compared to no burning. So I would say that the growth rate is not so different between burning and unburned. This is one thing that we have the document that showing that burning don't have any effect to teak growth. But the problem is that I mentioned before I finished my talk is about the frequency of burning. This is very important. Even though I just mentioned that burning don't have any effect to the growth rate of teak, but if you do burning every year, so there will be the problem for the teak plantation because you don't have the time for the teak, you don't have the time for the area to recover. That is the thing, because whenever you burn it, you destroy all the material. I mean the fertilization, the fertilizer, or you burn all the good fungi, bacteria, or any organic or organism in the forest floor that they need some time to recover. Imagine if you burn it every year, what happened to your plantation? So this is a very, very important thing that we have to concern. But for burning, if you burn this year and you keep unburned for 2 or 3 years, and you burn it again in next 4 years, yeah, it may be good. But if you burn it every year, the ecosystem will be damaged. So this is my answer. Thank you.
Yeah, thank you, Dr. Kopsak. Yeah, maybe burning is easy, right? But the control to the fire, we need more detail to implement for the prescribed burning, right?
Yes, they need more guideline. They need more guideline to do prescribed burning. That's what we need. Yeah.
Yeah.
They need more guideline. Yeah.
Okay. Is it clear? Okay. Maybe for the next maybe for Dr. Widianto, please you can respond the question.
Okay, thank you very much for the question from the Mrs. Hairi. So we can discuss later if not enough time for discuss. As the clonal tick categories for the fast growing species right there, I think how to say, not fast growing species, chickwood is chickwood as the normal chickwood. If we accelerated the growth, so we can see that species with fast growth performance, not fast growing species. If I think, in my opinion, yeah, so we can see that the normal or the natural ticks is normal growth of tick. So for clonal tick, probably how to say? I think it's better to say that the species with the high performance of growth, in my opinion. And the second, how to minimize the crack. Yeah, I think this still our challenge. For example, our treatment to do some crippling treatment can reduce the frequency and also the size of crack. But normally for the fast growing trees and fast growing, not only fast growing species, yeah, but also fast growing speed, fast growing performance, normally has the higher growth stress, and naturally the trees with the higher growth stress produce the high potential crack. Therefore, the curdling, several researchers reported that curdling is one of the effort to reduce the growth stress. Therefore, after we could reduce the growth stress, so the potential for the initial cracking also may be reduced, probably. It is needed to conduct such kind of research in the previous, in the next. Okay, and the second. Okay, thank you very much for the question. We evaluate the properties according to the British standard. So in the air-3 master content. So we conduct some treatment before the mechanical and physical testing. And the second, I think I need to choose the good sentence. I agree that the brighter wood, yeah, has a lower price, yeah, for the water to be good. But in my opinion, here I mean that I want to say that the clothing wood has the fresher, bright in the mean of the fresh, so not pale, yeah, dark and bright. Yeah, but in my opinion, here I used to kind of words, brighter and fresher. I think the fresher is better to express the situation of the girdling. So I thank you very much for your suggestion. So probably fresher is better without the brighter, because sometimes brighter means not black, and black, and the more black has the more value of chickwood, hardwood of chickwood. Okay, in this study, I would like to express the fresh. So not only not bright, yeah, not bright, but the fresh. Okay, thank you. That's all my answer.
Okay, thank you, Dr. Budianto. The last for Dr. Laxmi, you can respond to the question, please.
Thank you for your question. The first question, is it possible that the people will bring the small bunches of teak, making a charcoal for use in the household or sell in the market? Yes, I say that it's possible, surely. By concept, every material can be make a charcoal. But for teak, as everyone know that wood teak, I mean small stem, has much more value than being to make a charcoal. But for the small bunches, maybe you thin your teak in the forest plantation, or the small branch or twig that are falling down on the ground floor. You can bring those material to make a charcoal for cooking in your own household or for sale in the market. But as maybe you wonder, in my presentation, I also have use a small stem about 10 centimeters to make a charcoal. Maybe you wonder why. This is just my preliminary study. I want to know, actually I focus on the residue, the small bunch, but I also want to know what about the bigger one, is how about the energy potential of the bigger one compared with the small one. Is this your point? And the second question, fast-growing species. Actually, we do a lot about do research a lot about energy potential of fast-growing tea species. And in the presentation, I list only some species. Fast-growing tea species is, yes, of course, it's suitable to make a charcoal, because sometimes when we cut, it also produces a new branch. But if you mean in decoration, for charcoal, 1 kilogram of charcoal we can sell only 15 baht. But the charcoal for decoration, like a heart shape or animal shape, like I said in my presentation, 1 kilogram of charcoal can make the heart shape of charcoal about 20 pieces. That one pieces is 10 baht. So 1 kg of charcoal you can get 2,000 baht. It is a value added of the charcoal, 15 baht to 2,000 baht. Is this your point? Can I answer, right?
Okay. Okay, any feedback? Or is it clear?
Thank you.
Yeah, thank you very much for Dr. Laxmi for the response, for the answer. Yeah, all right. Unfortunately, we already reached the end of this session. I tried to take some notes in this session. Maybe first, we know fire have roles in our ecosystem as a bad fires and good fires, good fires as a part of the silvicultural treatment for controlling the pests. And the bad fire is a problem in our forest management. And it depends on its utilization and the impact of the environments. And silvicultural treatments is important to define the wood quality of the teak plantation. There's a lot of opportunity to study the silvicultural treatment and the impact on the quality of the wood. And for the speaker, for the charcoal, we will not use the charcoal for the energy, but also in aesthetical ways, right? For the flower face, right? And it's also beneficial. It's useful to solve the bad smell problem. So many ways that we can use the charcoal. Yeah, maybe that's all. Thank you very much for all the speakers. Very interesting session and an honor for us to learn from all of you. Also, thank you for all participants today. Hopefully, this session will be benefit for us. That's all for me. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Please be, hello, check. Please be remain on the stage because the organizing committee, check. Because the organizing committee will be present the token appreciation, but unfortunately, Dr. Kopsak, hello, Dr. We can send the token through Zoom meeting, but thank you very much, and we are waiting for you in the next agenda in Yogyakarta.
Yeah.
And we invite the Vice Dean for Academic and Student Affairs, Faculty of Forestry, Insinyur Dwiko Budi Permadi, SHUT, MSc, PhD, IPU, to present the token appreciation to the speakers. And for Dr. Widianto and Dr. Lasmi, please. Thank you, and once again, thank you very much, Dr. Kopsak, and see you in the next agenda in Yogyakarta. Thank you so much.
But Dr. Kopsak, we are very appreciated if you can join us until the ending of this program. Okay, ladies and gentlemen, now we are going to the lunch break time. So we invite all participants to enjoy the lunch on the hotel restaurant, and the next session will start at 1:13 p.m. So make sure all of you have entered the meeting room on 1:30 p.m. Thank you. Enjoy your lunch.
Check. Check, 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 check. Check, 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 check. Check, 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 cek, 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 tes, tes, 1, 2, 3, dicoba, cek, 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 cek. Cek, cek, cek.
Okay, ladies and gentlemen, hopefully we are energized after we have lunch because we will start the third session and we will invite the moderator who is present here. He is the lecturer on Forest Product Department, on Forest Product Technology Department, Faculty of Forestry, Universitas Gadjah Mada.
He was highly educated and awarded a Master and Doctor of Agricultural Sciences from Kyoto University. Honorably invited to the stage, Dr. Hairi Cipta Eshud MAGR. I will hand over the session for you.
Okay, thank you. Good afternoon, everyone. Okay, konnichiwa for other audience from Japan. And today we will have a presentation session. After this morning, we have two interesting sessions from our keynote speakers. And at this time, I will continue to moderate this session. We will have 5 presenters from various institutions. They will present their research about the clonal teak. So, okay, my name is Hairi Cipta. As mentioned by Master of Ceremony, I am lecturer from Universitas Gadjah Mada. So, okay, I will first, I will make sure the presenters are already here. First presenter is Mr. Eko Prasetyo, already here, okay. Mr. Abdurrahman Hashim, not yet. Mr. Zainal Mutakin, okay. Miss Anna, sorry, and Miss Rika. Okay, I will explain a little bit about this session. So each presenter will present their research in 10 minutes, and then we will continue with question and answer within 5 minutes. So please be on time for the presentation, and then we will move to the first presenter. And how about the PowerPoint file already ready? Okay. So please welcome Mr. Eko Prasetyo.
Okay, thank you for the opportunity. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Today I will share my work about bibliometric analysis for recent clonal teak research over 2 decades, from 2003 until 2023. My name is Eko Prasetyo, and my friend from National Research and Innovation Agency, named Indira Riastiwi. So next, why I need to do bibliometric study? We know that Tectona grandis is planted worldwide, particularly in tropic area. In America, there are 17 countries, in Caribbean 4, and 24 countries in Africa, Asia 16, and 4 countries in Oceania. So a lot of country plant the teak. And why they plant the teak? There are 3 reasons. So next, there are 3 reasons that teak is very popular in the tropical area. Okay, The first one is the Tectona grandis grew over a wide range of climatic conditions. It's from very dry until very moist. And the second one is Tectona grandis easy in establishment for plantation, easy to propagate, and pioneer characteristic. And the last one, and very important thing, that Tectona grandis wood is commercially valuable. So from this popular wood, a lot of research, as you already share from the day one and the day two, a lot of research about teak. And also, of course, a lot of publication in the Scopus and other publisher. And I would like to know the trend of clonal teak research. The method is we use FOSS viewer software. So the first one is extraction data from Scopus by keyword teak and the clone. Why I choose Scopus? Because the Scopus is the largest abstract and citation database. And then I choose 2 decades, 2003 until 2023. If no in this year, we not selected. And then if yes, we continue to analyze. The first one, I will know the country that research about teak, how about Indonesia, how about Malaysia, how about Thailand, maybe. I would like to know about that. And then the affiliation of the researcher and the keyword analysis, and then the type of publication and the number of citation. And the last one is clustering, title, and abstract by FOSS viewer. And why to decades? For information, in the Scopus data in 1966 until 2002, only found 11 articles, and we can conclude that clone or teak clone is popular only in the recent years. Is the result? We found 87 articles. We can divide it into 2 groups. The 8 is from proceeding, AIP conference proceeding, and IOP conference proceeding, Earth and Environmental Science, and 79 from journal. This 10 journal that mostly popular for publication of clonal teak. The first one is Journal of Tropical Forest Science, Silva Genetica, Tree Genetic Genome, and the last one is New Forest. And then after that, I clustering from the title and the abstract. From the result is we can divide it into 3 clusters. The red one is research material about teak clone, about the number, clonal seed orchard, about plant. And then the second one is about data analysis, the treatment, the effect of the data. The blue one and the green one is about growth parameter. So mostly researcher will research about the height, the volume, the development, the age, the DBH, and bridge age, about growth parameter. And then we move to the keyword analysis. So we analyze the keyword and the correlation. We can say that all keyword, the blue one, we can find in the 2005 is seed and orchard, trees, the clonal seed orchard, and so on. Is the we can call it the old keyword. I mean, in the recent years, there is no publication about seed again. And then the recent keyword is like the yellow one, agroforestry system, forest management, maybe thinning, physical properties, like Prof. Widi said about the physical properties of clonal teak. And the last presenter also about the physical properties. So we can call it the recent keyword. And then from this graph, we can know what next we can do. Maybe the researcher can research about clonal propagation or wood, about the wood quality, chemical, physical, and so on, and also like a biomass. This one is very small, very small comparing to the growth. The growth, the circle is higher than the biomass or the wood or the like a biomass. And also maybe tissue culture is very small circle. So we can say we can research about that, and maybe we can know the gap of the research. And then the next, the three countries, the biggest tick publication, Indonesia, Brazil, and India. We know that the native habitat of tick is from India, Thailand, Myanmar, and Laos. But in Indonesia and Brazil, also a lot of plantation. This is the number of the publication. And then the affiliation, Gajah Mada have 14 articles. Maybe applause for Gajah Mada. And then other, also Bogor, also other universities. What next? We can say we can collaborate, of course, other with the country and with the other institution. We can make a collaboration, exchange information, exchange data, and write and publish together. And then the next is top 5 citation is for 50 for clonal propagation, and for genome assembly a lot of citation, and progeny test, genetic origin, and clonal propagation. Okay, this is the last slide. The conclusion, we found 87 articles from 2003 and 2005 with various keywords, various countries, and various journal or proceeding. There's still opportunity for collaboration on various aspects of research, the collaborative global endeavor to unlock the full potential of clonal tick, the ultimately contributing to the development of environmentally and economically viable forestry strategies for years to come. So let's make a collaboration. Thank you.
Thank you. Thank you for your presentation. Sorry, the microphone is not working. Yeah? Okay. Okay. Thank you for your presentation, Mr. Eko Prasetyo. Okay, we will have a question and answer session. If you have any question regarding the presentation, please raise your hand. Okay, is there anyone have a question? Okay, I will have one question. Do you find any collaboration within country, between different institutions within country, or different institution with another country? I mean, yeah, with different countries.
Okay, thank you for the question. Yeah, actually, we will do that analysis. So in this opportunity, we don't analyze the collaboration between researcher, but from voice viewer, we can also make a relation about the collaboration, but not yet done in this occasion.
Okay, thank you. Okay, we have another 3 minutes. If you have any question. Okay. Okay, now another question. Okay. Okay, thank you for your presentation. Please give applause for Mr. Eko Prasetyo. Okay, for the next presenter is already here, Abdurrahman, Mr. Abdurrahman? Not yet? Okay, we will move to another speaker. Okay, Mr. Zainal Mutakin. Please welcome to the stage. The title is about resistance of tick clones to mistletoe infestation in clonal seed orchard in Padangan, Perhutani, Indonesia. Okay, time is yours. Yeah, you can.
Assalamualaikum warahmatullahi wabarakatuh. Good noon, everybody. I would like to present about resistance of the clones to mistletoe infestation in clonal seed orchard, Padangan, Purtani, Indonesia. As the early, what is the mistletoe? I think mistletoe is known the most people, especially mistletoe on teak. In teak conventional and teak clone is a macroparasite plant which has hemiparasite. Actually, mistletoe have leaves, so can self photosynthesis, but the root attach to house tree via austerium as modification of root. The consequence of mistletoe attacks, but the decrease leaf assimilation capacity, decrease growth capacity, conversely exercise growth. For example, with the formation of gales, swelling, and sometimes the appearance of diffuse broom symptoms and ITC. The mistletoe butter is integrated by butter of pest and disease of the tree, as said by Professor Rahayu, the before presented. Until the present, the attack of parasite on teak stand in the Brutani area has expanded in terms of area and distribution, include teak clonal seed orchard. The stick early to control mistletoe butter tree is how to identify mistletoe. 1. Observation and identification through making sample plots. 2. Morphological identification. 3. DNA barcoding to find species of mistletoe more accurately. The following is some research of my works in making dissertation in ABB. 1. Observation and identification through making sample plots. We make the PCP placement design, and PUP in PCV refer to efforts CRC modified for this study. In here, the size of plots 5T multiple 5T. In the PCP, there are PUP. The size of 5 meter multiple 5 meters, and the some treatment are control the infestation low, F1 until 8, 3 that taking of mistletoe, moderate 9 until 60, and heavy more 17. Morphological identification, to identification the mistletoe species is via morphology, and more accurate via DNA barcoding. We found the species of mistletoe have been found in Padangan, namely Dendroputu pentandra, Macrosolen gonus and Viscum articulatum. Dendropoto, Pentandra, and Macrosolen tetragonus are the hemiparasite, but Viscum articulatum is a hyperparasite because it's ground on Dendropoto and Macrosolen. And the following, we have DNA barcoding to find the species of Mislito is accurate data. We found based of in-gain bank, we found that Dendropoto and Tetragonus in near cluster and include the Loranthaceae and Viscum articulatum as hyperparasite include Xanthalaceae family. What is the intensity of Mislito attacks on tick? We observe via crown divided to three parts: upper crown, middle crown, and lower crown. In every the part of crown is divided to the center location crown and right and left crown. And average number of left Mislito in each BUP in KBK Padangan in control found around 2 Mislito per tree, and moderate little more 2.5 and high until 4.5. The next. This is Mislito distribution map and CSU Padangan. Here the number of tick clones observed was 144 clones, of which 139 clones were attacked. Around 17% were attacked, and remain only 5 clones were not attacked by Mislito. Only 3%. Best of today, the 5 clone is resistant to Mislito are clone 6, 126, 138, 148. But now condition are a clone 103, 9 and 143 now were cut because progenitus remarks as lower category. Kemudian while clone 6 nearly planted 1963, but not planted continuously because plus 3 had center pruning, and now remain 102, 6 and 103, 8 is resistant to Mislito. So only 2 clone is resistant to Mislito. We think I do this research about those a clone to we tested in nursery and the feed of 3 clone, those 2 clones. Finally, I get the propagation 2 clones untuk 2 planted in the area of teak have butter of mistletoe. Finally, our recommendation for further research, collaborative research needs to carry it out to obtain teak clones that are resistant to mistletoe. Control technique for mistletoe on teak actually we done, apart from applying pruning technique. Further research is needed by the Cepu forestry regarding other control technique. They are effective and efficient. Include direction for more intensive teak misplanting pattern, spraying etipon as biological to reduce the viability of mistletoe seeds. Biocontrol, and the final alternative is contact herbicide application. Although herbicide application impact to the bed environmental. Finally, the result of the research can be applied on wide scale planting to GSO. Thank you for your attention.
Okay, thank you very much, Mr. Mutakin, for your presentation. Okay, if anyone have a question regarding this topic, please raise your hand. Okay, 1, 2, okay. Please, okay, your turn. Okay, you are next, and then the first, Dr. Sabto. Please.
Me first?
Yeah.
Okay, thank you. My name is Sabto from UGM. Yeah, I want to ask about the impact of the mistletoe. Is there any impact, any significant impact of the mistletoe on the seed production? We know that this is a GSO, clonal seed orchard, so it is very important for us to increase or to maintain the plantation in order to produce seeds properly. But if there is mistletoe, maybe it will give negative impact. Is there any significant impact of the mistletoe to the production of seeds? And then is there also any different, what we call, different impact on each clone to produce seeds regarding the mistletoe attack? Thank you.
Okay, thank you. Okay, maybe we will move to another question. So, please.
Thank you very much. I am Benjalat Prompen from Royal Forest Department, Thailand. I would like to know that you said that there are lots of clones attacked by have been attacked by mistletoe, but you said that you have 5 clones that do not have attack. Why? I want to know why. Thank you very much.
Okay, thank you for your question.
Sorry, diulang. Ya.
Okay, please, Mr.
Well, thanks,
Mutakin, to
Mr.
answer the questions.
Sabto, ya?
Yeah. Pak Sabto.
Thank you for your question. I know until now there is no research about impact the tick clones and GSO to production seeds. So not cannot conclusion what mislead to the bad impacts to seed production. Include research about seeds from tick clones to infield, especially tick clone is takes mislead to. Maybe the next time we try to impact production seed in tick clones invitation of Wislito.
Okay, Dr. Sabto, is it clear for you? Okay. The next question is about why the 5 clones was more resistant. I think that's the question.
Thanks for the second question. Sorry, the second question. That times, the result of my research, there is 5 tick clones found now mislead. The reason is maybe those tick clone maybe have the bulk of stem is more harder, so the root of mislito cannot grow to a branch of in crown tree. I think only a little statement because I search more continuously about this. Why the 5 clone is not infected by mislito. Yeah.
Okay. Thank you for your answer. Okay. Is there any question? Oh, okay. One more question, please.
All right, my name is Mirza and I'm from Gajah Mada University. So my question would be, do you have any recommendation to the KPH, I mean Perhutani, specifically KPH Padangan, regarding those 5 clones that are not affected by the mistletoe? Thank you.
Recommendation. Sorry, could you repeat the question?
Do you have any recommendation to the KPH Padangan regarding those 5 clones that are not infected from your research?
Okay.
Yeah, thank you. My recommendation are important to control CSO in Padangan. Until now, Cepu Center done by pruning the branch of crown. Although this is a little effective because can to butter crown structure, and I recommendation for 5 clones. After that, we saw research about the 5 clone to testing resistant to mistletoe, and so I can mass propagation to a seedling, so it's planted in the field. Yeah.
Okay, thank you, Mr. Zainal Mutakin, for your presentation and your answers. Okay, we will move to another presenter. So, thank you for your presentation. Give applause to Mr. Zainal Mutakin. Okay, for the next presenter, please be prepared, Miss Anna Hoyrul Lutfia from Universitas Gadjah Mada. The title of the presentation is The Effect of Residual Stand Distance on the Growth of 7-year-old Coffee Stick in KPH Ngawi. Okay, are you ready? Okay, time is yours.
Check. Okay. Okay. Good afternoon, ladies and gentlemen. My name is Anna Hulvia. People also call me Anna. I'm a Bachelor of Forestry from Gadjah Mada University. It's an honor to be here, and I would like to present my research. That was my final task when I was a student in Gadjah Mada University. With the title is The Effect of Residual Stand Distance on the Growth of 7-year-old Coffee Stick Tectona grandis in KPH Ngawi. Next. So Indonesia is one of the three largest timber exporter in the world. And even in 2021, the demand for Indonesian teak wood in domestic and foreign market has increased. So to meet increasing the demand, it's highly productive teak is required, so that it can be cut with a short cycle, less than 20 years. One of the alternative is copy system. The copy system we can call terobosan in Indonesia is a natural regeneration from the cut stem of a harvested tree. What is the advantage is the copies have early growth is faster than the seedling and seeds. And because it has a larger root system from the parent tree. And the copy system is simple and efficient both of the time and the cost. Next. Development of teak plantation using copy system can be undertaken after the thinning process of teak. The development of teak plantation using a copy system after thinning will create a double cycle. The long cycle for the copies as a new stand, and the short cycle is a residual stand. Teak thinning at 83% intensity with a strip system will create an even-aged teak forest, and variation in teak plant growth. It is because the different level of shade and competition. So a study on the growth of teak copies after thinning is needed, which is expected to help the designing appropriate silvicultural treatment to support the growth of teak copies after thinning. Next, okay. The research was conducted in August 2022 in plot 7H RPH Gendingan BKPH Kukuan KPH Ngawi. With the location is Widodo District, Ngawi Regency, East Java, Indonesia. Next. Okay, the research it was conducted in Perhutani copies treatment plot that have land area 2.064 hectares, with the previous stand is clone of ticks from PHT1 and PHT2, and by plant spacing 3 meter by 3 meter. And it received treatment by thinning 83% intensity in 2015 that we form as a copies, and 70% remaining to be a residual stand. And then in that plot, there is 6 plant blocks, which is every plant block consists several rows of unit treatment. And one treatment unit has 7 stands, 5 copieces, and 2 residual stands. Those there were 3 variations of distance from residual stands: 3, 6, and 9 meters. And a distance 12 meters can analogize by 6 meters from the different direction, and also 15 is 3 meters from the different direction. So we collecting the data by census 100% of residual stands and copies. We collecting the parameter growth of residual stand and copies, diameter, total height, ball height, crown width, and outer crown height, that will be processing us in SecCFS to know the stand structure projection, and in Microsoft Excel to know the growth of residual stand and the copies. Next. And then to know about competition index, I use the Hegi method. There is a method with relationship in the diameter and the spacing. Okay, next. And for the canopy openness and leaf area index, I use the hemispherical photography and will be analyzed in gap-like analyzer software. The data was collected in 11 times every treatment unit, and every block I was doing 5 repetition treatment units. And I also take the light intensity with lux meter to support the data of canopy openness and leaf area index. Next. And the data analysis, we use the MANOVA, and here the result of discussion. I will tell the condition of copies treatment unit. We can see the difference of dynamic landscape change in 2016, 2020, and 2022. From the data obtained by census on the residual stand and copies, it was found that the treatment units in the field were not completely complete. So there were some treatment unit with no residual stand and no copies. We can see from the data obtained there's no same the number of the tick and copies and residual stand. The incompleteness of the treatment units in this study will affect some the data obtained, which may also affect the statement that not all of them have the tendency to be directly proportional to existing theories and justification. Next. Okay, here the result for the first. We can see the canopy openness and light intensity. That both of them have the similar result. That variation of the residual stand distance is significant effect to the canopy openness and light intensity. And we can see that, we can see that copies from the distance of 3 from the residual stand have lowest value of the canopy openness and light intensity. The closer the copies is to the stand, the more copies will be shaded or get the less light. So the different less light indicates the level of competition that occur above the surface canopy in the form of competition of light. And then the highest of the canopy openness is the copies with the distance 9 meters from the residual stands. Next. For the leaf area index is opposite to the canopy openness and light intensity. The value is opposite because leaf area index has the highest value in copies thick from the distance 3 meters from the residual stands, and the lowest is from copies from the 9 meters from the residual stands. Okay, next. And then the competition index is the highest competition index value is in the copies of 3 meters from the residual distance. The higher the competition index value, the heavier the competition with neighboring trees. In other words, the copies is more stress. So the heavier competition is to the closer the copies is to residual stand, the smaller of the growing space, the more shaded and competing with the residual stands. Next, we can see the competition index in here. So this is fraction of the plot. One of block the unit treatment. We can see how what is that? Okay, we can see here the plot. Next. Okay, we know that it also will affect in the growth of the copy stick. We can see that the diameter from copies at the distance 3 meters from the residual stand has the lowest value and the highest in the 9 meters from the residual stand. We can see also the distribution diameter class. There's more. It's dominated in 10 until 15 centimeters. Okay, next. In the hair growth is also affected by variation of residual stand distance. But in the bull hair is not affected by the residual stand distance. From the total height, we can see that also the highest total height is in the copies of 9 meters from the residual distance, and the lowest is from the 3 meters from the residual distance. Next. Okay. I tried to comparison of the diameter and height values of thick from copies, clone and seed propagation. From my research in 2022 and from Rahmawati 2021, the clones and the Himapan et al. In 2017, the generative and the copies. I'll try to compare with the same years, with the same age, but different in the location and the treatment, and also especially in the plant propagation system. We can see that from my research, we compare the copies, will compare the clone with the same age, is the clone still have the better growth in the diameter and height values, but when we compare with the generative or the seed, is copies is more better than the generative. This is because the difference of root system, that the copies has a larger root system, so it has access to water and nutrition from the soil than the generative. But when we compare the copies and clones, we can see that maybe it is the same place, but it has a different growth because the first growth of the clone is because come from the PHT1 and PHT2 clones in 2015, which are still new and young or juvenile. But in contrast of copy stick, it's also from the clone PHT1 and PHT2, but is from 2002. And then we know that the sort is from a stem or residual stand, so it's already old. So it is possible that the growth and the quality genetics material have decreased through the age. Or the difference of this.
Sorry, Miss Anna, time is
Alright.
up, so you
Okay.
can
Just
make
for
it faster.
the,
Yeah.
Okay, just the
Okay.
conclusion.
Okay.
Okay, for the conclusion, variation of the copies descent from the residual stand affected the canopy openness, the value index, competition index, and the growth of thick copies after thinning activities in thick stands. From 3, 6, and 9 meter distance variation, copies at the distance of 3 meters had a poor growth, while copies at the distance 9 meters from the residual stand had the best growth because it had a low level of shading and competition. Thank you.
Okay, thank you very much,
Thank
Miss
you.
Anna, for your
Okay.
presentation. Okay, next is discussion time. So, is there anyone who want to ask question about this topic? Okay, Miss Anna, I have a question. So, you took some photograph for the canopy and also measure the light intensity. What time did you take the picture? I mean, maybe different time will affect the the result.
Okay. Yes, thank you for the question. I took the picture at maybe 8 o'clock until 10 o'clock. Then I will take a rest because there it will affect when we took the picture at 11 until 12 because the light is too shining and it will affect the image that I took.
Thank you. For audience, do you have any questions? Okay, thank you for your presentation. Give applause to Miss Anna. Okay, before we move to the last presenter, I will call again for Mr. Abdurrahman. Are you here? Okay, maybe we will move to the next presenter. The next presenter is Miss Rika Bella Rahmawati. Please come to the stage. Okay, Miss Rika is from Universitas Gadjah Mada. The title of the presentation is Clonal Teak Initial Spacing, Effects on Growth and Wood Quality in East Java. Okay, yeah. Are you ready? Okay, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Thank you for the chance to present at the International Teak Seminar. I'm Rika Bella Rahmawati. I'm from Faculty of Forestry, Universitas Gadjah Mada. It's an honor to have this opportunity. And now I and our research team with Professor Suryo Hariwinoto, Professor Widyatno, Professor Budiadi, and Bapak Aris Wibowo from Perhutani would like to present our study about clonal teak initial spacing, effect on growth and wood quality in East Java. Okay, I will start with introduction. The lowland monsoon forest is one of the tropical forest types dominated by teak. As we know that teak is one of the most important hardwood species because of its strength, durability, and high economic value. In Indonesia, teak forests in Java are the largest, with about 60% of the total production forest area in Java. That more than 40% decline in forest and land productivity. Therefore, rehabilitation efforts to superior cone selection are needed to enlarge productivity. Some research suggests that teak clones will produce high growth, causes the canopy to close weakly. So, growing space management is a crucial silviculture consideration. It can be done by choosing initial spacing. Moreover, Clonal Teak Plantation were developed to produce timber for construction with high diameter growth is one of the requirements. So spacing management needs to be adjusted to enable the teak plant to grow optimally and produce good wood quality. With the development of the science, teak plantation began to be designed with a larger spacing to increase teak productivity and also accommodate agroforestry system. Some research suggests that wide spacing can improve teak growth, but does it affect the wood quality of teak clones? Therefore, research on the effect of spacing needs to be carried out to support the future sustainability management of Clonal Teak Plantation. Okay, for the methods, the research was conducted on teak plantation in Perhutani, Ngawi, East Java, used a 7-year-old and an 8-year-old clonal teak planted in 2011. The initial spacing used was 4 spacing. There are 3 meter by 3 meter, 6 meter by 2 meter, 8 meter by 2 meter, and 10 meter by 2 meter. The research design was LGBT with a 4-block as replication. Okay, this study is a summary of previous studies with additional growth and wood quality parameter, such as diameter increment, current annual diameter increment, current annual productivity, compression perpendicular to grain, and also the hardness. The data obtained were analyzed using SPSS software with analysis of variance. Okay, this is for the research and discussion. The spacing significantly affect on diameter, volume per hectare, ball height, and then a branch angle. We can see on the graphic that a diameter increase with increasing plant spacing due to the increasing space to growth that help crown and root development and also reduce competition. On the other hand, increasing spacing reduces the volume per hectare due to a decrease in the number of individuals per hectare, and also reduce ball height and increase branch angle. Low ball height and a large branch angle cause more wood defect that reduce the wood quality of the clones. And for this reason, teak planting with wide spacing must be followed by intensified maintenance, such as pruning. Pruning maintenance activity is an alternative to produce good wood quality. Okay, how about the annual diameter increment and productivity? The diameter increment increases insignificantly as the spacing increases. This results in a large diameter and also increase the selling price of the timber. And while the productivity increase until the spacing 8 meter by 2 meter, and then a decrease at wider spacing. It because the productivity per hectare is influenced by stand density. This result is very good according to Corret and Cherubini. The productivity is considered excellent with the volume gain per hectare until 20 meter cubic per hectare per year. Okay. Okay, this is for the second parameter with quality. The spacing had no significant effect on hardwood percentage. We can see on the graphic that 6 meter by 2 meter is the larger of hardwood percentage than the larger or the wider spacing. It's because the rapid growth in diameter will increase the amount of juvenile wood in the tree. The proportion of hardwood is an important factor in determining thick wood quality and also increase and the selling price of the market. Okay, we can see the absolute diameter of hardwood and softwood. Wide spacing has a higher hardwood diameter than narrow spacing. However, the softwood diameter is also higher at wider spacing, while the 6 meter by 2 meters had the lowest proportion of softwood with a large enough of diameter. So the 6 meter by 2 meter spacing produced the highest percentage of hardwood. According to Moya and Paris, that hardwood percentage is influenced by stand density and also on the diameter. Okay, for mechanical properties of clonal teak, that this research showed that spacing had no significant effect on all variables of the mechanical properties of clonal teak. The plant spacing of 6 meter by 2 meter is dominated and the highest value. It means that wider spacing can increase or can improve the growth, but relatively reduce the mechanical properties of clonal teak. And the static bending, such as modulus elasticity and modulus rupture, as the indicators and in determining the strength of wood, included in class 3 and 4 strength. According to Seng, 1990, it indicates that the clonal teak at 8 years old could be acceptable for a variety of wood products, both indoor and outdoor application. Okay, from this presentation, we can conclude that wide spacing can increase the diameter increment and the productivity. An increase in teak diameter will increase the selling price of the teak in the market, but increasing spacing show in a larger branch angle and the lower ball height that affect the wood quality. So pruning should be more intensive to produce a good wood quality. On the other hand, increasing plant spacing didn't have a significant effect on all variables the wood quality. This indicates that increasing spacing can improve the growth without significantly affecting the physical or mechanical properties of the clones. And the arrangement of growing space can provide space for the teak clones and also accommodate the intercropping plants. Crops can be extend under a teak plantation at wider spacing in the early or advanced stage of clonal teak plantation. So selection of superior clone and environmental manipulation such as spacing can improve the growth and quality of forest product. Therefore, it can support the productivity of lowland monsoon forest. Okay, this is for the reference. And that's all for our presentation. Thank you so much for your kind attention. Wassalamualaikum warahmatullahi wabarakatuh.
Warahmatullahi wabarakatuh. Thank you very much, Ms. Rika. Okay, now it's time for discussion. Do you have any question regarding these topics? Okay, one. Is there any? Okay, please.
Thank you very much. Good talk. My name is Tani from the Jirukas, Japan. So I think that Plutani has two types of the super cheek. So I want to ask you about this clone. It consists of the one single clone or two super cheek clones?
Could you repeat the question and louder?
Yeah, I know that Plutani uses two super cheek clones.
Okay.
So your study plot consists of the one super cheek or two types of super cheek.
Okay, thank you.
how much super tree in this research. Is right? Yeah.
No, I mean that Purumpurutan has 2 types of the super cheek clones.
Yeah.
Yeah, so your plot consists of the single super cheek or 2 types of super cheeks clones.
Oh yeah. Yeah.
Okay, please.
Okay, this study is used the 2 base clones, 97 and 110, and in there are in 4 blocks, and there are 4 randomly and in 2 clone randomly planted in the teak clone plantation, and that is for two clone in completely planted in the plantation. So this is randomly for the best 2 clone.
Okay. In this case, your plot has 2 super chick clones. So if possible, you can identify which type of the clone, and then you put this information into the statistical model to explain the effect of the clones and also the this spacing. This study become more interesting, I think. Thank you very much.
Okay.
Suggestion.
Okay. Thank you so much.
Okay. Thank you for your suggestion and questions. Okay. Is there anyone who wants to ask a question? Okay, I have one simple question.
Okay.
So, do you have any hypothesis why the larger diameter did not have better wood mechanical properties?
Thank you for the interesting question. I try to answer that why the spacing had no significantly effect on water quality. It's depend on the data obtained that this clonal teak is at here that the water quality or such as hardwood percentage, hardwood proportion is the formation of the hardwood proportion is at 4 years, and this clonal at here is the growing for the formation for the growth, and there's wider spacing increase the juvenile wood, and this the indicate that not significantly on the water quality.
So dominated by
juvenile. Yeah.
Okay. Okay.
It based on the data obtained.
Okay. Right. Thank you very much for your presentation and also your answer. Okay. Give applause to Miss Rika. Okay. I think this is the end of the first presentation session, and after this we will have another announcement from the Master of Ceremony. So I'm Hairikta. Thank you for your attention and participation. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, ladies and gentlemen, thank you for the speaker and also the moderator, Dr. Hairi Cipta. And before we go to the next session, we have a coffee break. And please enjoy the coffee break that has been prepared and served at the corner. And we will start the next session at 3:15 p.m.
Thank you and enjoy your coffee break time.
Check.
Ladies and gentlemen, now we are going to the last session. Actually, we have 5 titles to be presented that stated on the schedule, but unfortunately, this afternoon Professor Widiatno and also Miss Yusulinawati cannot join with us. So we just only have 3 titles to be presented this afternoon.
Okay, ladies and gentlemen, in the next session, we'll be led with our moderator. He is a lecturer from Forest Product Technology Department, Faculty of Forestry, Universitas Gadjah Mada. He was highly educated and awarded Master and Doctor of Forestry Science from Forestry Faculty Universitas Gadjah Mada on PMDSU program, the Master Education Scholarship towards Doctorate for Excellent Undergraduates.
Ladies and gentlemen, please welcome to the stage Dr. Rizky Arisandi Eshud. Dr. Rizky, I will hand over the session to you.
Okay, thank you for the MC. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Welcome to the last session for today. For the last session, I will explain to the rule for the discussion. Maybe different with previous session. We use the panel system for the presenter and discussion. Today we have 3 presenters to present about some title, and it is my pleasure to invite all presenters to the stage. The first, Dr. Emma Suraya, and the second, and Dr. Yeni Ratnaningrum. Please to the stage and for the presenter. And in the last, we will discuss about the topic. Thank you. Okay, ladies and gentlemen, Dr. Emma will present the topic about high-resolution aerial photograph for 3-volume modeling of Clonal Teak in Wanagama 1 Edu Forest. Dr. Emma, time is yours.
Thank you very much. Allow me to stand here. This is what do you call it? Critical time. Very sleepy time, yeah. I'll try to, perhaps not able to entertain you in that way, so however, try my best. Okay, I will present our research with my student using the aerial photograph that we get it from drone, and then we try to have a model to predict or to estimate the individual trees volume based on the data that we have from aerial photograph. The intro quite simple, yeah, because of the high value of teak, and then we really need to know how's the standing stock we have. at least like that. Even one of my teachers said that because of the high value of teak, we should put CCTV on each of one trees, yeah, because very expensive. We will need to take care of it very good. Like what other research that already presented in this today, we are seeing that the inventory part is also important. However, we also know that the inventory, but if it's we do it terrestrially, directly in the field, solely, we will need very high costs, very high time consuming, and then also we need manpower, and also we need, really depends on the stand condition as well. And then the technique and also the science from GIS and particularly remote sensing is now developed very advanced, and we can use it to help us in doing this inventory, even for individual trees, because of the value of this very high value of these trees. Okay, so the objective of our research is to develop estimation model from high resolution aerial photograph data for the volume of clonal teak tree in Wanagama. In this research, we're still doing it sort of manually. We say it visually on screen. We're trying to delineate the crown of each tree, and then we measure some of the trees as sample trees using their deviates and also total height. And then we try to compare both, not compare, what's the more precise term for, trying to predict the volume from the individual trees from the data that we can see from the aerial photo. The data that we are trying to measure is the crown diameter. Whoopsie, what did I do? Can you put it back? Not to me, sorry. I should use this, yeah. Next. We use the crown diameter as the data to measure, and also the tree height. The tree height from this remote sensing data, we get it, we analyze it from digital surface model to have what we call it as canopy height model. So the technique is so straightforward. I don't want to make you extra dizzier in this afternoon, yeah. And then based on that, we're trying to fit the data into several implicit models, regression, very simple. And then we tried to have whether the best models able to predict the volume that we measured standing on the field. This is the clonal teak that been planted in Wanagama. We call it as Jati Mega. We planted in 2000, start from 2004. Approximately now it's based on the measurement from the photos, the area are about 9 hectares. And this is the tools and data that we use. We use the aerial photo that we gathered in 2019. Recently, we tried to take some photos, aerial photos again. However, because of the long drought, the leaves are shattered, so we don't get the crown ideally to do these models. Very sad of that. But however, we also trying to use the same data, but not doing it manually. We're trying more to, what do you call it? To dig more on the availability of artificial intelligence, deep learning, machine learning, to ask the computer to recognize the pattern, and also trying to have the model. So when the computer see the picture and then the result sort of come out without very specific model like what we're doing here visually or manually. And then there is also that data that already conducted in 2021. This is a different photo. We use it as a comparison, yeah. And then digital surface model, DSM in 2019, and also the boundary data, and also inventory data from the stand as the primary data. The field data that we are trying to do, we use 65 trees that we choose purposefully to sort of cover the variance of the population. And then we also measure more detail to have tree stem shape for the F factors, and then use more trees as the model development. And for each tree, we measure the diameter at the base and DBH, diameter as base height, trunk height, and also tree total height. And then also for the tree stem shape, we also measure some diameter at different heights, 2 meters, 4 meters, 6 meters, and also at TBBC, what we call SS trunk height, without the branches, and then also trunk height and also total height. And for the volume of the tree, even the picture, this is laid down trees, but however we use spiegel reloscope to measure the diameters for each section, and then calculate the volume of the tree using Smalian volume. And then we calculate the volume and also find the tree form. And we'll get the volume of each tree as the dependent variable. And then for the each of X, the first one is crown diameter delineation. We're trying to find the diameter of each trees. It's quite challenging because of the shape of the crown of the teaks are not sort of uniform. We really need to find variations as the samples. And then the second X is the canopy height model. We're trying to calculate from digital surface model reduced by digital terrain model. So digital terrain model is, we assume there is bare land there. So the what do you call it? The subtraction between DSM to DTM, we will get the canopy height model. So this one is the approach or the proxy to get the total height of the tree to have the measurement. And then we try several models to fit the data, multiple regression, this additional usual, quadratic, exponential, logarithmic, power, polynomials, and sigmoid. And then after we try all of this, and we also, after we get the best, we test the classic assumption about normality, heteroscedasticity, multicollinearity, and also the validation of the model. We also calculate the deviation aggregate, deviation average, and also NMRS normalized root mean squared error. And then this is what we got as the samples. The minimum, this is wrong. Diameter in meter is the minimum crown is 4 meter, and the maximum is 10 meters. The average is at 6. And then for the height, this is we know that it's error. Yeah. And then the highest is 24.87. And then this is the prediction of the volume. And based on the result, we are trying to compare all the models, and we found out that the exponential and also polynomial give a better compared to the other models. And also we test with the regression ANOVA and also FTEST. It's showing that the models are significant, and also we're trying use the t-test for the both variables, and also so it's the exponential model perform better compared to the model 6. This is what we call as polynomial model. And the result, this is the model that we got. And based on the R square, it gave us very confidence, because the 80% of the variation of the volume can be predicted by the diameter of a crown and also the height that modeled from the height model. And this is the result from the classic assumption tests. All are good. Normality, it's the data, the residual showing normals, heterogeneity, no pattern in that. And for multicolority also for both don't have any multicolor. And then we are also trying to use the validation, using deviation aggregate, this is deviation average, and also NRMS. All are saying that the results are good. And this is the conclusion, my last slides, that we can use this equation to predict the individual volume using the data from the photo. This approach, like what I said in the beginning, we're doing it visually. And now we are still exploring the research using the artificial intelligence to use digital data that kept in the remote sensing data, and also teach our the machine to give us the best prediction for the trunk volume. That's all. Thank you very much for your attention.
Okay, thank you so much, Dr. Emma, for the very interesting presentation. We are going to the next presenter. The next presenter is Dr. Yeni. Dr. Yeni will present about the two topics. The first topic is the neck, the phenotype performance and reproductive ability of thick Tectona grandis plants in a 35 years old provenance trial in Wanagama. And the second topic is phenotype performance and sheet production of the thick plants in 29 years old seed source trial in Wanagama. Dr. Yeni, time is yours, please.
Thank you very much. Good evening, ladies and gentlemen. Thank you for having me. Yeah, my name is Yeni. I am the last presenter today, and I will have two presentations, so it's gonna be a long way. So I hope you don't mind if I just sitting here. But I will try to have it as fast as possible. So. Okay, I will start with my first presentation about the phenotypic performances and reproductive ability of tick planted in a 35 years old provenance trial in Wanagama. And this research is conducted by our team of the Tree Improvement Laboratory, Faculty of Forestry, Universitas Gadjah Mada. So for the background, next please. Okay, for the background, we have a reason why this research is important. Since the tick planting program needs a constant supply of planting materials with better genetic adaptability and reproductive ability to ensure the best performances and yield. However, on the other hand, we face a problem with the limited number of the improved stands and also this insufficient supplies of good seeds. Back then seeds were mostly collected from identified seed stands, seed production areas, or even unidentified sources. Okay, next please. Yeah, recently we all have the much rely on the vegetative propagation, but in some point it has disadvantages in relation to, of course, the more complex techniques and more expensive costs. And the most important thing is the long-term use of identically genotypes might also reduce the genetic diversity. This is the most important thing. So I suggest that along with the mass vegetative propagation, using only in the best few genotypes, we should provide the best individuals for seed sources. And this is important to maintain gene bank which preserve more genetic diversity, and also provide materials for hybrid trials, so a breeding population, and can be the alternative for planting material supplies. Okay, and the next we will see what we have here. So in 1988, Wanagama has established the provenance trials, which is consisted of the progenies originated from various provenances in Indonesia and other countries. Here we have two from the East Java. Also, we have one from Madura. Also, some from Central Java. Also from Muna Island. Also from India. Include the Malabar ones. Yeah. Also from Timor, Thailand, and Burma, Myanmar. Okay, next. So the objective of our research is to evaluate the survival and phenotypic characters after 35 years and select the individuals with best phenotype for the sources of propagation materials. The second objective is to estimate the seed production of each provenance and select the best individuals for the sources of seed materials. And also we will design the conversion into a more genotypically improved seed sources. Okay, next. Here we have the study site, which is 35-year-old tick provenance trials in compartment 17 of Wanagama. It has a RCBD trial, RCBD design with 5 blocks, 4 tripods, and 4.4 meter spacing. And also it consisted of 21 provenances. Okay, and the next, there are the site characteristics of its provenances. Next. Next. And the procedures. The first, we evaluate the survival and phenotypic characters of each individual in the provenances. And then we select the individual with the best phenotype, which will be the sources of vegetative and reproductive propagation materials. And after that, we also estimate the seed production of each provenances, and we also select individuals with best phenotype and most abundant seeds. It will be the sources of seed materials. And the last, we will design the conversion into the seed sources, the better seed sources. And what we have on the results, next please. For this most survived provenances, for the best, we have the Malabar, Central Province, and Burma ones. And in contrast, the lowest survival, there are Kauai, Kowok, these two are from India, and one is from Pati, Central Java. We move to the next result. For the growth performances, we measure the plant height and stem diameter. And for the plant height, we have Kauai, Deling, and Bangilan for the best, and Kowok, Thailand, and Soy for the lowest. And for the stem diameter, we have the Deling, Malabar, and Kauai for the best, and Kai, Liron, and Soe for the lowest. And the next, we also estimate the flower abundance and find that the most abundant flowers was achieved by the Ling, Kai, and Ponorogo, and the lowest flower production was gained by the Pati, Central Province, Central Java, and Thailand. Next. We also observe the fruit production within 2 years from the 2018 and 2019, and we found that there are also consistent results for the best fruit production. We have in 2 years we have Panggilan, Deling, and Cepu, and for the lowest fruit production within 2 years we have Pati, Thailand, and Soe. And next we will see the map of the individuals bearing fruits in 2018, and the next is the similar result for the year 2019. Okay, next. So for the seed production, we have the best provenances, which is Cepu, Panggilan, and Deling, and the lowest seed production is the Pati, Thailand, and Soe. Okay, next. So for the results, we make a recap, and we can see here that for the selected provenances, we see that Deling and Panggilan are the best in many phenotypic parameters. Kauai, for this case, is also the best in this phenotypic aspects. However, it performed the lowest survival. Here in the table, the underlying provenances are the priority to be removed. The first are Kai and Ponorogo, because they have the lowest performances, but produce many flowers, so it will make it will cause the pollen contamination. We also have to remove Pati, Kauai, Thailand, and Soe, since it has also the lowest phenotypic performances. The provenance having star here, Malabar is one which under considerations. It means that we have to reconsider if it will be selected to be thinning for not, because the Malabar performed the best survival and stem diameter, but it has the lowest stem form. So next, please. Here the example of provenances with best performance. We have in the left is Panggilan and Kauai in the middle and Deling in the right. Next. This is a provenance under consideration, Malabar, because it has a big diameter and high survival, but the stem form is not that good. We can see here it compared to the Panggilan ones, the stem. So the Panggilan has the best stem form, and the Malabar, in contrast, it has the lowest score. Okay, next, please. I put myself in the middle, so we can compare the diameter of the trees. The left we have the best one among the best, Kauai, and another four is the lowest characters, provenances with lowest characters, which is Soe, Thailand, Soe far behind, Thailand right behind me, Kauai and Pati in my left side, we have also pati. Okay, next. Yeah, this is the provenances with lowest performance but heavy flowering. So we have removed it first. In urgent needs to be removed. Ponorogo and Kai, it has the lowest performance but heavy flowering. So we have a recommendation here. Next, please. Okay, the selected provenances are the Deling and Bangilan, which is the priority for the plus-risk candidates and can be the sources for propagation and breeding. For the Kawai, this is important here because it also have the best phenotypic characters, but it performs the lowest survival. So it is a need to provide the better environmental manipulation and specific sites for this provenance.
Sorry, Dr. Yani, please fast.
How many minutes?
1 minute again for the first percentage. 1 minute.
Oh, okay, 1 minute. Okay. I will go fast. Okay. And the underlying provenances, which is priority to be removed, and Kai and Ponorogo, because this is have the lowest performances, but produce many flowers, so it may cause the pollen contamination. And also we have 4 provenances, which is pati, soy, Thailand, and cork, which are also the lowest performance. Malabar should be taken into consideration because it has the best survival and stem diameter, but the lowest stem form. So it can be used only in specific purpose, in example, rehabilitation of critical land and to make wood chips. Okay, and the last slide. So to be converted into the more genetically improved seed source, it is still possible with several upgrading activities, which is, because there are variations which is mostly found among provenances, so we will conduct selective thinning based on provenances. The first to be removed is pati, soy, Thailand, Kai, and Ponorogo. We should also maintain individuals, okay, and provenances with the best phenotype and having abundant flowers and seed production. Also develop flowering stimulation and pollination management. And the last is the best performance but less flower individuals can also be managed for vegetative propagation. Okay, this is the end of my first presentation. I think we will move to the second, before discussion.
Before discussion,
okay.
Maybe about 7 minutes. Is it okay, Dr. Yani, to present it?
Okay, we can move to the next slide.
Please, next slide. It's okay. To audience, maybe can list of the.
I already sent the file to the organizing committee. I sent it to Mirza previously.
Okay. Okay, I'm sorry. Maybe.
And I have it. Actually, I have it here.
Yes. Maybe we will discuss.
Have you found it? Yeah. Okay. So this is the very last of my of the presentation today. Yeah. Actually, this is same tema, and I also run same methods, but in different plantation. This one is the teak planted in 29 years old seed source trial. Previous we have the provenance trial, and now there is a seed source trial. Okay, next. So actually Manakama has the collection of progenies originated from various seed sources in Java, which was planted in a seed source trial in compartment 14. It was initially intended to re-evaluate the quality of offsprings in terms of survival and phenotypic performances. Okay, I will move forward to the objectives. Yeah. Here we evaluate the survival and phenotypic characters after 29 years and select the individuals with best phenotype from the sources for propagation materials, both seeds and vegetative. And also we estimate the seed production of the best individuals from the sources of seed materials, and we measure the correlation between phenotypic characters and seed production. Here is the study site, and this is the teak seed source trial in which the materials were collected from 10 KPH in Perum Perhutani, and we got in the 157 seed lots from the collections, and then it planted in RCBD design with 40 plots each, 5 blocks and 3 meters, 0.3 meters spacing. But in our last inventory in 2023, out of more than 300 trees planted, it only 1,400 trees left. So this is a 46% survival. Okay, you can see in the provenance. Yeah, the seed sources are Kendal, Semarang, Pati, Kebonharjo, Mantingan, Blora, Cepu, Randu Blatung, Purwodadi, and Gundi. And the procedures, same with previous procedures, but here we also add the measurements on the correlation between phenotypic characters and seed production. And for the results, yeah, phenotypic characters varies greatly among sources and individuals. Move to the next because I will show the pictures. Yeah, it is easier to show with the pictures. Yeah, here we have a very greatly variation among sources and among individuals. Next, after the measurements, we have the best rank. There are some individuals having the best rank for 4 traits, and also best rank for 3 traits. Another is for 2 traits, and there are also only 1 trait. Individuals with best phenotype are mostly originated from these sources. The first are Randu Blatung and Semarang, followed by Mantingan, Blora, Cepu, Kendal, Purwodadi, Kebonharjo, Pati, and Gundi. Maybe it will be more clear if we see the tables next. Yeah, this is the rank of the best 25 seed lots from for each the phenotypic characters. We measure 4 characters, which is categorized into the quantitative traits and qualitative traits, which is a total height, pole height, stem diameter, and the score for the stem and branches. So, and we have these ranks. The yellow color represents provenances which gain the best rank for the 4 traits. And the orange color represents provenances having rank in the 3 traits, and the gray one provenances having best characters, best rank for the 2 traits, and in the green one it only best in 1 trait. Okay, next. When we conduct the scoring for to select the plus trees, to select the plus trees candidates, out of more than 1,000 survivor trees, only 76, so only 5% are scored more than 60, according to the scoring manual for the plus trees issued by the forestry ministers. Okay, next we also measure the seed production only for the best individuals. We measure seed production only for the 50 best individuals, and we found that only 18 out of the 50 observed to bear fruits. Seed sources with the most abundant seeds are Mantingan, Blora, Pati, Randu Blatung, Cepu, Kendal, and Semarang. And also we have the individuals with most abundant seeds. We can see here, and the yellow color represents individual which have best rank in 4 traits, the orange in 3 traits, the gray in 2 traits, and the green one only 1 trait. Okay, and then in the next slide, we will see the individuals which are best in ranking and also produce many seeds, which are Cepu, Randu Blatung, what is PR? Randu Blatung, and also here the Blora, and also Mantingan. Next, we run correlation between traits, and we found that branch abundance are positively and strongly correlated to the fruit production. Plant height is positively correlated to the diameter, but both height and diameter were negatively correlated to the pole height. And for the conclusions, we have, basically only 46% trees are survived recently, and out of these survived trees, only 5% are scored more than 60. So, the phenotypic characters varies greatly among sources and individuals. So, these individuals with best phenotype.
But please, 1 minute again.
Yeah, how many?
1 minute.
Okay. Only 18%, 36%, out of the 50 best trees were observed to bear fruits. So I will jump into the recommendation. Next, please. Yeah. So since the phenotypic characters varies greatly among sources and individuals, so the best phenotypes will be the parent candidates for the seed orchard, both vegetatively and seed materials. The best phenotypic characters which produce many fruits will be the parent trees for seeds and breeding purposes. The number 3 is important also. So because only 5% of these trees are scored more than 60, so it means that the stand performance is below average. So for the last recommendations, it still can possible to be converted into the more qualified seed source, but we have to make many upgrading activities. The first, we have to make a selective heavy thinning based on phenotype and individuals. Yeah. Also, we have also conduct flowering simulation and pollination management. And the individuals with the best phenotype and abundant seed production will be in the materials for propagation and breeding populations. And trees having good phenotype but less or unable to flower will be in the parent for mass vegetative propagation. Again, this is the end of my presentation. Thank you very much for your attention.
Okay, once again, thank you so much for the presenter. Give applause again for our presenter. The next session is the discussion. Maybe we have about 7 to 10 minutes, maybe. Please, is there any question? Please show your hand. Okay. Miss, please mention your name and your institution.
Assalamualaikum warahmatullahi wabarakatuh. Thank you for the opportunity. My name is Dian Fatina Aprilia from Gajah Mada University. So my question is for Dr. Yeni about the first presentation. So one of the objectives is select the individuals with the best phenotype for the searches of propagation materials. That I know there are several methods to select the best phenotype of tree. So what method did you use to select the best phenotype, and do you recommend it? Do you recommend the method to select the best phenotype for the different species that, as I know, you are also expert in tree improvement for eucalyptus and sandalwood. Thank you.
Okay, thank you for the question. Maybe the next other question. Is there any question? Okay, Miss, please. Oh.
Okay, good afternoon.
Okay,
So
maybe
for,
after,
okay.
yes.
For the last presenter for the 2 papers, actually the last paper, the result was quite complicated, considering that there was unobserved differences among individuals. So you have your recommendations, but just a clarification that would it be intensive in terms of silvicultural management if you are going to proceed with the recommendations? And also, do you think it would be economically viable if we are going to address the concerns among variation in terms of individuals? For me, variation in seed sources will be at least manageable in terms of different provenances, but among individuals would be quite complicated if we are going to proceed with all the recommendations that you provided to us. So something that I would like to know your thoughts about that concerns.
Okay, thank you. This question addressed to Dr. Yeni. Yeah. The next question, maybe, please, Miss.
Okay, my name is Mirza and I'm from Gajah Mada University. So my first question is to Mrs. Soraya, Emma. I mean, my question will be, does your method can also predict tree height even when all the leaves fall down or molt, especially in dry season? Okay, that's my question. Thank you.
Okay, thank you for the question. Two questions to Dr. Yeni. Please answer the question. And the next, Dr. Emma to answer the question. Please.
Okay, thank you. For the first question, Diva, could you please explain it in more specific way? Do you mean with the methods of selection or methods of scoring the plus trees?
Okay, that I mean is scoring the tree.
Scoring the plus trees?
Yes.
Okay. Yeah. For the TIC, we have the standard for scoring the plus trees, which is same for in every site which planted by TIC, they will have same standard. So this is issued by the governance, by the what to say, Kemen LHK, yeah, issued in 2006. This the standard consisted of how to measure the plus trees candidates for the qualitative and quantitative characters, also complete with the scores like that. So we just input the data and make it connected it to the scores, and then we make it we count this, we accumulate the scores in total like that. So I make the selection based on this manual. Is this answer your questions?
Okay.
I think she has the second question. No? Oh, no, actually no. Actually no. Because every species has its own specific character, so the scoring will be different. And also it depends on the purpose of the management of the plants. For example, from the sandalwood, we harvest the oil from the stems, the hardwood. So the plus characters is not similar to the teak. Yeah, and also another example from the kajuput and the eucalypt, which produce oil, and the plus characters are related to the sineal production, maybe the number of leaves, the biomass, and so on. So yeah, every species and every management purpose has different scores, different characters to be scored, just like that.
Okay, maybe the next question from.
It's okay. Okay, thank you. Another question is from Miss. Yeah. And you just clarify why the thinning is different between the provenance trial and the seed source trial. Is it correct?
Asking if in terms of economic feasibility, because there is a large variation in terms of among individuals. So in terms of addressing silvicultural management or operations, it will be quite complicated and probably financially, intensive compared to if if there is variation among sources.
Oh, yes.
So, although the recommendations are good, but addressing individual differences will be, if it's economically viable, if I will put into further or future plantations.
Okay, yeah, I got it. Yeah, I will try to answer from the economic perspective, although this is more related to Bu Emma field, yeah. But yes, it's because the last plantation has the below average, below average performance. So if we try to keep them all, it will cause the degeneration of the offsprings, because the not good stands still have pollen which will mate with the best ones. So it will cause the genetic degeneration. So if we want to upgrade the seed sources, we have no choice. We have to cut all the bad ones. But it's gonna be a lot money. I am agree with you. But we have no choice if we want to upgrade the seed sources. So that's why I make the priority which one will be selected first for thinning. So we will conduct it in multi-years like that. But thank you very much for your questions. Is it answer the questions? Okay, thank you.
Okay, thank you, Dr. Yani, for the answer. The next question addressed to Dr. Emma, please, the answer.
Thank you very much, Ms. Mirza, for your questions. For this research, we are choosing the samples for the trees that are still, the crown is still attached. Like what I said, in this years we also tried to take the photos for the stands. However, because of the drought, there is no leaves attached to the trees. It's quite difficult to analyze this kind of condition. However, we are now trying not at the level of individual, but for the, what do you call it? It's for the per hectare volume. So for stand volume. So we tried counting the individual and then try to make the average, and then we make the model to predict the stand volume instead of individual tree volume. Is that answering your questions? Can I ask Bu Yeni? I'm trying to what? I wonder, is there any, like what already presented before about the mistle 2 for these trees? Because like I'm trying to continue what Pak Sabto asked. What is the consequences if the mistle 2s attack our trial trees, that for the first, and then the second is about the climate change. We know that several times we experience prolonged drought. Is it also affect the quality and also the quantity of seeds produced by the trial trees? I'm very new, a beginner in this field.
Thank you, Bu Emma. Actually, this is also our big considerations about a mistle too, but I don't know, maybe the more specific and detailed observation have been made by the laboratory. Yeah, the forest protection laboratory. But I notify in the field that the mistletoe attack is more affected by genotype, genetic aspects. So there are provenances which never attacked by mistletoe, even they are very close in planting. So this one attack, this one is not. Similar provenance attack, another provenance not, like that. So I wonder, and I just assume that oh, it is more genetically influenced, like that. Yeah. Actually, climate change destroy our observation. I have to tell you that I observe the flowering from the first bud until the fruit maturations, and it never reached the maturity. Yeah, in the middle fall, and then again floral buds, and then another abortion, and then again another abortion due to the climate change, and it destroy in the same with the same it destroy in the same heavy destructions, both the wet season and the dry season. In the very wet condition, all the flowers and pollen are gone, and in contrast, in the most warm and the warmest condition, it will also destroy all the flowers, like that.
Okay. Thank you so much for the presenter, the answer. I'm sorry, due to the limitation of the time, we will close the discussion. Give applause for the presenter, our presenter, and thank you so much for the attention. We close. Wassalamualaikum warahmatullahi wabarakatuh. I back to Master of Ceremony. Thank you so much.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Emma, Dr. Yeni, and also the moderator, Dr. Rizky. Least but not least, the honorable welcome to this room, Dr. Sigit Sunarta, our Dean. Honorable distinguished speaker, ladies and gentlemen, we have come to the end of International Teak Seminar. We would like to invite Dean of Faculty of Forestry, Universitas Gadjah Mada for closing remark. Please welcome Insinyur Sigit Sunarta, Shud, MP, PhD, IPU.
Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, good afternoon. I'm really sorry to apologize to you that because yesterday and today I couldn't accompany you, to attend this seminar. But I'm very happy that up to the end of this symposium, you still enjoy to attend this symposium. And I will read out about closing ceremony. I would like to extend my heartfelt gratitude to all of you for your active participation in this symposium. Your presence and contribution have been instrumental in making this event success. And more importantly, it is in generating valuable insight and knowledge that will undoubtedly benefit our lives. Teak, as main plant species discussed during this symposium, hold a special place in the heart and life of people, not only for Indonesia, but also in various countries across Asia. It is versatility and wide range of application, from house frame and furniture to handicraft and flooring, underscore it is important in our daily lives. It serves as testament to the significance of sustainable forestry practices and the responsible utilization of our natural resources. The key to ensuring the continued availability of teak and meeting the ever-growing market demand lies in effective breeding strategies. Breeding programs play a pivotal role in enhancing the productivity of teak plants, and the knowledge shared by our experts over the past 2 days will undoubtedly contribute to the advancing this important field. I trust that this symposium has served as catalyst for fostering collaboration and knowledge exchange among researchers, furthering our collective effort to improve teak breeding techniques and sustainable forestry practices. Once again, I would like to express my sincere thanks to all of you for your valuable contribution and active engagement in this symposium. With this, I officially close this event, and I look forward to witnessing the positive impact of our collective effort on the future of teak and forestry in our region. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Dr. Sigit Sunarta. Ladies and gentlemen, last but not least, we cordially invite all participants to join campus tour and also enjoy the dinner at Bumbu Desa Restaurant after this closing ceremony. We will start from the hotel lobby at 5 p.m.
And we would like to invite you all of some refreshment next morning. Please join us at the field trip at KPH Ngawi, East Java. We will start from the lobby at 7:30 a.m.
Well, that's wrap our event. On behalf of the Committee International Teak Seminar, thank you all for making time to join with us today and also yesterday. But after we close this seminar, we have photo session again with Dean of Forestry of Faculty, Universitas Gadjah Mada.
And it has been our pleasure to host this event. We look forward to seeing you at next event. Good afternoon, and I have one pantun to close this international seminar. Ikan hiu,
ikan sepat,
sore-sore meeting.
Cakep.
Thank you so much for coming. Wassalamualaikum warahmatullahi wabarakatuh. And please, we invite all of you to have a group photo session. But once again, we announce agenda this